Hello there, and welcome back to this quiet corner where we let science unfold at the speed of deep space, slow, steady, and full of quiet surprises. Tonight, we're not talking about ancient civilizations or wandering mammoths. No, tonight, we're staying in the present, or at least, we think we are, because this is a story about trust, about data, and about the strange little object that has astronomers whispering in their coffee cups, 3I Atlas. It's the third interstellar visitor ever confirmed to have entered our solar system, after Oumuamua and Borisov. It's moving fast, too fast to be from here, and it's doing things that, frankly, don't make much sense. NASA has released the numbers, the trajectories, the light curves. Everything, they say, is fine, ordinary, routine. But if you look closely, if you follow the details the way astronomers actually do, something doesn't line up. Imagine stepping outside tonight and looking up at the quiet dome of stars. Somewhere out there, beyond the reach of our eyes, an object is slipping through the dark, a fragment of another system, older than our sun, untouched for billions of years. It should be a rock. It should behave like a rock. But 3I Atlas didn't. Its path curved ever so slightly in ways gravity alone couldn't explain. Its brightness flickered like a pulse. Its spectrum hinted at materials that shouldn't survive in interstellar space. Now, picture yourself there in the observatory, the air thin, the hum of instruments steady, and a small point of light moving across the screen. You don't expect to see deception in the stars, but the data feels massaged, adjusted, corrected, as the reports call it. NASA insists it's normal solar radiation pressure, cometary outgassing, nothing to see here. But every few months, a quiet correction appears in the database, shifting the numbers just enough to make the story neat again. Maybe you're listening late at night, the world dim and still. Maybe you're half asleep already, the rhythm of this story syncing with your heartbeat. Funny, isn't it? We trust the heavens more than we trust ourselves. But what if the sky, too, keeps secrets? So before we drift deeper into this mystery, leave a quiet comment if you'd like. Tell me what time it is where you are, and whether the night sky is clear. Because tonight, we're not just watching the stars, we're questioning the storytellers. Settle in, dim the lights. Let your thoughts slow to the pace of orbital mechanics. Because before we decide whether NASA is lying or simply protecting us from something they can't explain, we need to understand what 3I Atlas really is, and why its path through the void doesn't behave like anything we've seen before. And so, before we chase the light, we go back to where it began, the moment someone first noticed a speck on the edge of the solar system, moving just a little too fast. Let's start where all quiet chaos begins, with a telescope, a dark sky, and a researcher who probably just wanted to finish their coffee before the next data upload. You're sitting there now, in the control room atop Haleakala, high above Maui, where the air feels like chilled silk, and the stars crowd the horizon like gossiping lanterns. The room hums with the soft whir of machines that never sleep. Outside, the wind scrapes along the volcanic rock, whispering in a language older than light itself. And somewhere between those breaths, a pixel flickers, a single, wandering spark across the night's perfect calm. The Atlas telescope, built to watch the heavens for troublemakers, asteroids, comets, anything big enough to ruin everyone's week, catches something that doesn't fit. Its motion is fast, far too fast. Its path, slightly off from what gravity alone should allow. It's like spotting someone running upstream while the whole river moves the other way. You lean closer to the screen, squinting at the faint streak. Maybe it's a cosmic bug, you think. A glitch, a bad calibration. But deep down, something about the pattern it traces feels intentional, tidy, deliberate. You zoom in, enhance, process. The noise clears, and there it is again. A slim line of light, moving with purpose across the stars. Boots on sand, light on land. Shadows stretch like a painter's hand. That's the first image it conjures in your mind. Something walking, softly, against the flow of time. The observatory hums on. The monitors blink in soft rhythm, like the room itself has started to breathe. You upload the coordinates. The telescope tracks again. The object's name will come later, 3I Atlas, but right now it's just the anomaly. Eyes like glass, stars that pass, whispers buried in cosmic grass. It's a strange comfort, realizing how small you are in comparison to what you're seeing. Haleakala feels alive at this hour. The volcanic soil still radiates heat from the day, and the scent of old rock and chilled metal mixes in the air. Somewhere down the mountain, a gecko chirps, probably unaware that above its tiny head, history just bent a little. You check the readings again. The object's velocity exceeds escape speed, too quick to be bound by the Sunday. Whatever this is, it didn't come from here. You can almost feel the edges of reality tilt. For a second, it's as if the telescope itself blinks in disbelief. Dust in flight, silver night, hearts awake in borrowed light. Your team begins to whisper. Someone jokes that it's another rock, another hunk of frozen boredom. But even through the dry humor, there's that undertone, the quiet tremor of discovery. The coordinates are logged. A follow-up observation is scheduled. Meanwhile, you step outside. The wind greets you with that thin, high-altitude hiss. The horizon glows faintly where the Pacific holds the moon's reflection. You can almost imagine the object out there, tiny, defiant, skating through gravity's grip like a moth refusing a flame. Skies so wide, worlds collide, secrets sleep where comets hide. Back inside, the data keeps coming. The streak is steady. Its light flickers, not randomly, but with a rhythm that feels almost conversational. You wonder if it's spinning, tumbling, or maybe just pretending to. Cold air sings, metal wings, silence hums, and data clings. You remember something your mentor once said, that every discovery begins as an inconvenience, and right now, you are very, very inconvenienced, because this thing isn't behaving. It's accelerating, slightly, but measurably. You cross-check, recalibrate, then double-check again. No mistake, no cosmic prank. It's not the first time an object's moved strangely, of course, but this one feels different, intentional, in its defiance. Through the haze, numbers blaze, stars align in subtle maze. Morning begins to stretch across the slopes of Haleakala. Light creeps through the dome's narrow window, golden and almost apologetic. You sip coffee gone cold. The world outside wakes to tourists and birds, but in your small circle of glowing screens, the universe feels closer than your own reflection. Lines that bend, truths pretend, stories start but never end. The team uploads the coordinates to the minor planet center. Within hours, other observatories begin to notice it too. Data floods in from Chile, Arizona, Japan, everywhere. The same result. It's not one of ours. You look again at the screen, the light curve rising and falling like a breath. Somewhere between the pixels and the silence, you feel that human twinge of suspicion. the one that has followed every great discovery since Galileo. Maybe we're not looking at what we think we are. Stars that weep, secrets keep. The void remembers, though it sleeps. The object moves on, steady, indifferent. The world below continues spinning, as if unaware that something alien just brushed against its field of gravity. You send the report, close the logs, and exhale. But even as the sky brightens, something lingers, a faint sense of being watched, not by eyes, but by trajectory. You can almost hear the object hum through the void, carrying a message too simple and too enormous for words. Dreams unspool, data's rule, truth hides behind a cosmic fool. And just like that, 3i Atlas is born into human record. An intruder, a messenger, a mathematical rumor dressed in light. The observatory quiets again. Somewhere, your heart mirrors that rhythm, the pulse of a secret not yet told. The morning wind sighs across the dome. You stretch, blink, and smile, because tonight you'll point the telescope again, and somewhere out there, a faint streak will still be moving, defying gravity, pretending to be nothing at all. Let's drift forward now, to the moment when the scientists realized this wasn't just a local oddball. It was a tourist from somewhere far beyond. You can almost hear the collective groan ripple through every observatory on Earth. Not again, someone mutters, recalling the brief, chaotic fame of Oumuamua, the first gatecrasher to wander through our solar system uninvited. And now here's another one, this time with a Hawaiian postcard name and a personality problem. 3i Atlas, a rock that doesn't act like a rock, gliding through the void like it read the laws of motion and decided they were more like guidelines. You sit at your screen, the data scrolling like cosmic poetry. Every line of code, every plotted point tells you the same thing. This object isn't staying. It came from the deep, maybe the space between stars, maybe even the echoing dark between galaxies, and now it's leaving, headed for nowhere in particular. Its orbit isn't closed, it's open-ended, like a sentence that never finds its period. Picture that for a moment. A visitor so fast it can't be caught, so free it belongs to no Sunday. You try to imagine where it's been past frozen exoplanets, through the faint halos of distant systems, across light years of silence. It's like a seed flung from one garden to another, crossing the cold void in eternal bloom. The data doesn't lie, though it does enjoy a good riddle. The eccentricity greater than 1, the velocity beyond solar escape. No gravitational tether, no return ticket. It was here for a heartbeat, and already halfway gone. You zoom out on the model, the blue curve of Earth's orbit shrinking against the backdrop of the Sun, Jupiter, Saturn, and beyond. The path of 3i Atlas slashes across that tidy symmetry like a diagonal scratch on a record. The solar system, once orderly, now looks startled. You can almost hear it gasp. If astronomy were a dinner party, this is the moment someone strange walks in, doesn't say hello, rearranges the cutlery, and leaves before dessert. And everyone just sits there, holding their spoons, wondering if that really happened. The astronomers, of course, try to stay calm. They make graphs. They publish preliminary notes. They say phrases like likely hyperbolic orbit and probable non-gravitational acceleration. But you can sense it underneath the professional language. There's a quiet thrill, because deep down, every scientist is a gossip for the cosmos. And gossip this good doesn't come twice in a career. The observatories across the world start to hum with attention. Chile, Arizona, Mauna Kea, each one pointing their mirrors, hoping for another glimpse before the visitor fades back into the dark. The excitement feels almost human, like a collective leaning forward. You can feel it too, the kind of curiosity that keeps you awake long after midnight, staring at the ceiling and wondering if the stars ever gossip about us in return. Now, here's where it gets odd. The brightness curve begins to pulse again, not like a normal comet shedding dust, but rhythmically, soft increases, soft fades, like the universe is breathing through a paper straw. NASA calls it rotational modulation. You call it weird. The words mean the same thing, really, depending on your funding situation. At this point, 3I Atlas becomes the celebrity of the scientific world. Headlines buzz, another interstellar object found, second visitor confirmed. What are the odds? Spoiler, astronomically small. And yet, here it is. Think about that. In the unfathomable vastness of space, with distances so big we measure them in light years, this tiny sliver of rock or whatever it is happened to cross paths with our little blue marble twice in just a few human years. Either the universe has an impeccable sense of timing, or it's trying to get our attention. Theories bloom like dandelions. Some say it's just interstellar debris, fragments flung from a collapsing system, drifting endlessly. Others suggest something more deliberate, maybe a probe, maybe a sail, maybe something we'd call technology, if we weren't afraid to lose our research grants. You lean back in your chair, rubbing your temples. Outside your window, the night feels thicker somehow, as though it's listening. You wonder if, right now, someone or something on another world is watching a faint blue dot move oddly across their sky, labeling it in their own language as anomalous. Maybe they're calling us 3I Earth. Funny thought, isn't it? We always assume we're the observers, never the observed. Yet here we are, staring at a cosmic traveler and realizing that maybe, just maybe, it's returning the gaze. The calculations confirm what your instincts already know it's leaving. No slingshot maneuver, no slow spiral, just a clean escape into infinity. Soon, it will fade beyond even the reach of our largest telescopes, its faint reflection swallowed by the interstellar dark. But before it goes, it leaves a question behind a small, shimmering splinter in the collective human brain. How many others have passed this way without us noticing? How many times has the sky held secrets just beyond our instruments, laughing softly in the language of light? You close your laptop, the glow dimming against your face. Somewhere out there, 3I Atlas is still gliding, indifferent and perfect, carrying with it the dust of unknown suns. You imagine it coasting through emptiness, silent, untouched, and somehow watching. The thought is both terrifying and peaceful, because if visitors can come from elsewhere, then the universe is not empty. It's alive with motion, with messengers, with quiet hellos disguised as comets. And maybe, as you drift towards sleep, you realize something simple and absurdly comforting. The cosmos doesn't need to shout. Sometimes it just knocks once on the door, leaves a trail of light, and disappears before you can say thank you. Let's pick up where curiosity starts to ache a little when déjà vu creeps in, and the scientists realize they've seen this movie before. Only the ending made even less sense the first time. 2 years earlier, a different speck called Oumuamua had slipped through the solar system like a cosmic paperclip. Long, thin, metallic in sheen, tumbling end over end. Nobody could agree what it was. Asteroid, comet, spacecraft, space banana. It vanished before anyone could finish arguing, leaving behind the scientific equivalent of a raised eyebrow. So, when 3I Atlas arrived, the world braced for clarity, and instead received a sequel that forgot to explain the plot. You can almost feel the tension in the observatories, a sort of interstellar déjà vu, mixed with academic caffeine addiction. Not again, someone sighs, clutching a mug labeled Comet or Bust. The graphs start to resemble old ones from 2017. The same impossible acceleration, the same gentle defiance of gravity, the same feeling that the universe is trolling us with style. Oumuamua was supposed to be unique, a one-time fluke, a cosmic pebble tossed from another star. But 3i Atlas rewrote that assumption with a smirk. You picture astronomers staring at their monitors, blinking slowly, like cats who just watched the curtains fall twice in a row. The data comes in clean at first. Trajectory, brightness, composition. Yet every new measurement hums with something faintly familiar, like a song you can't name. Both objects had those delicate nudges, as if sunlight itself were giving them a little shove. Radiation pressure could do it, sure, but it's like watching a leaf dance against the wind instead of with it. You imagine yourself up there on the mountain again, wind slicing across the dome, the universe enormous and smug. You whisper, "You again?" into the eyepiece, half expecting the cosmos to wink back. NASA keeps its voice steady. The press releases arrive with that practiced, calm tone. Nothing unusual. The same phrase they used last time. But even you can tell the subtext reads, "Please don't make us deal with this again." The scientists compare notes. Both objects hyperbolic, both on outbound paths, both accelerating just a little too much. The odds of two such visitors appearing within a human heartbeat of cosmic time, tiny, microscopic, like catching two falling snowflakes, shaped like question marks. You think about how the universe loves repetition. It's built on rhythm. Stars pulse, planets orbit, galaxies spin. Maybe this is just another rhythm we haven't recognized yet. A celestial heartbeat we've only now begun to hear. Still, you can't help but laugh softly at the irony. Humanity spends billions searching for life, then panics when the universe throws a shiny breadcrumb our way. No, that can't be intelligent, we insist. It's just physics being playful. You picture Oumuamua and 3i Atlas, like two tourists, snapping photos of our sun before heading home. One slender and glinting like polished steel, the other crumbling, bright, but equally evasive. Both leaving behind unanswered emails in the inbox of astrophysics. Somewhere in a quiet corner of the internet, theories bloom like mushrooms after rain. Light sails, alien trash, forgotten probes from civilizations older than our continents. You scroll through them at 2 a.m., half amused, half uneasy. After all, the idea that someone else might be sending postcards through the void feels strangely intimate. You can almost hear Oumuamua whispering through the years, "Did you miss me?" And 3i Atlas replying, "Just checking if you've learned anything yet." The humor helps, but the questions stay. If these objects are natural, why do they act so oddly alike? And if they're artificial, why so quiet? No beacon, no code, no invitation, just motion. Pure, perfect, impersonal motion. Maybe that's the point. Maybe civilization out there doesn't communicate with words or light, but with gravity itself, nudging objects like notes across the fabric of space-time. We just haven't learned to read them. In the dim light of your monitor, the simulations keep looping. The paths of Oumuamua and 3i Atlas cross in a visualization, not literally, but thematically, like parallel brushstrokes on the same cosmic canvas. You feel a shiver, not of fear, but recognition. It's strange, isn't it? How repetition makes mystery feel heavier, not lighter. One anomaly is curiosity. 2 is a pattern. 3 would be doctrine. Somewhere, An astrophysicist probably just added, "Pray there isn't a fourth to their to-do list." You lean back, eyes tired, heart oddly full, because even though the data is infuriatingly incomplete, it's also beautiful. Two objects from the infinite, each breaking our rules, just enough to remind us we don't own the universe's manual. You imagine them still drifting out there, Oumuamua ahead, 3i Atlas following like a younger sibling trailing after its cool older brother, the distance between them stretching wider every second, yet somehow linked by the shared absurdity of having once brushed our Sunday. Soon, both will be beyond reach, fading into silence again. But they've left fingerprints on our understanding, tiny, elegant smudges reminding us that cosmic order is just chaos wearing a bow tie. As you close your eyes, you realize something comforting. The universe doesn't repeat itself out of boredom. It does it to teach us patience. The next visitor, whenever it comes, won't clear the mystery either. It'll just make the pattern richer, the story stranger, the night sky a little more alive. And for now, that's enough. Let's step into the part of the story where calm voices mask shaking hands, and where scientific language becomes its own form of stage makeup. NASA's press release arrived like a lullaby, polished, unthreatening, and written with the kind of precision that could tuck even the most skeptical mind into bed. A hyperbolic comet with typical dust production, they said. Case closed, science adjourned, everyone go home. But underneath that tranquil announcement, the people who had stared longest at the data were quietly realizing that typical was becoming the most suspicious word in the English language. You sit there, watching the briefing stream on a flickering monitor. The spokesperson's tone is almost hypnotic, deliberate, soothing, bureaucratically serene. You can imagine the memo beforehand: don't speculate, don't dramatize, stay within protocol. Behind the podium, the NASA logo glows like an all-seeing pupil. Every sentence is carefully weighted, engineered to produce exactly zero excitement. And yet, your pulse quickens. Because if the story were truly simple, they wouldn't be repeating it so often. The journalists in the room nod politely, jotting down notes they could have written before they arrived. Hyperbolic comet, dust, outgassing. The words are safe, predictable, familiar. It's like calling a shark a wet fish enthusiast. The phrase does its job, it hides the teeth. Meanwhile, the data sits quietly online, whispering contradictions. The light curves wobble, the trajectory doesn't align. The so-called dust production happens inconsistently, almost deliberately, as if the object occasionally remembered to act like a comet to keep up appearances. But nobody mentions that in the press release. You can almost feel the tension in the room of scientists back at Haleakala. They've been told to use phrases like consistent with, not, suggests, to say within, uncertainty, not, unexpected. The official narrative must be smooth as glass. But in private Slack channels and coffee-fueled Zoom calls, the questions hum like background radiation. What's typical about an interstellar visitor? What kind of comet disintegrates without fragments? Why does every attempt to model its acceleration produce numbers that look like jokes? You imagine someone typing furiously in a dim lab, muttering, "The math hates me. The media eats it up, of course." NASA confirms natural origin. Experts say, nothing to worry about. The words fall like rain over a campfire, hissing, smothering, cooling the curiosity that had begun to catch flame. That's how you handle anomalies. You bury them in normalcy. And yet, you can't quite let go. You start scrolling through the archived PDFs, the small print appendices, the calibration logs that never make the headlines. You find small edits, numbers adjusted, models updated for consistency. You think about how bureaucracies treat truth the way cats treat furniture, occasionally scratched, but never fully destroyed. Somewhere between lines of metadata, the story begins to split. Officially, 3I Atlas broke apart from solar heating. Unofficially, the breakup pattern didn't match known fragmentation events. It wasn't chaotic, it was clean, controlled almost, like a staged exit. NASA said the object had simply ceased to cohere. You can't help smiling at that. It's such a gentle way to describe something leaving without goodbye. Behind the scenes, an unspoken rule takes hold. You don't ask too loudly. If you do, your funding renewal might cease to cohere too. So instead, scientists do what scientists do best. They code their doubts into cautious footnotes. Additional mechanisms may be at play. Further study recommended. Academic. 4. We have no idea. Outside the professional sphere, the internet does what it always does. It spirals. Forums ignite. YouTube thumbnails bloom like alien spores. NASA, hiding the truth. New object from another civilization. You scroll, amused and exhausted. Somewhere between hysteria and apathy lies the real question. Why does the truth always need a PR team? You start to realize that official stories have a rhythm. First comes discovery, then excitement, then reassurance. The same cycle, again and again, until the public's curiosity resets like a screensaver. The machinery of calm is beautiful in its efficiency. Press releases, interviews, Twitter threads, each word a small tranquilizer dart aimed at collective wonder. Meanwhile, the telescope teams keep watching. Unofficially, of course. They compare faint frames from independent observatories, looking for something NASA forgot to mention. A flicker here, a residual trail there. One scientist swears she saw a faint glint even after the disintegration date, too symmetrical to be dust. But she deletes the note before saving the draft. You picture the control room late at night, screens dimmed, the hum of equipment like a slow heartbeat. The last traces of 3I Atlas flicker and fade. You can almost hear the sigh through the static. It's gone. Let's just move on. But you can't move on. Not really. Because now you know how silence sounds when it's carefully engineered. It's smooth, symmetrical, and politely final. The universe, on the other hand, is never polite. It shouts in photons and screams in gravity. When something moves through it quietly, that's when you should worry. NASA's calm face remains on the broadcast, frozen mid-sentence as the video buffers. Typical, the caption reads beneath the paused frame. You smile softly. Nothing about the universe has ever been typical. Not its birth, not its stars, and certainly not this strange visitor that arrived, lied down in the data, and dared us to notice. Because the real story isn't in the press release. It's in the silence that followed the quiet hum beneath the official words. The one that said, "We're not sure what we saw, and maybe we don't want to know." Let's move now to the part of the story where light itself starts behaving like it's in on the joke. In astronomy, brightness is truth. A steady shine means stability. A flicker means story. And when 3I Atlas began to flicker, astronomers did what astronomers always do when the universe starts whispering too loudly. They called it an instrumental issue. You're sitting there again, surrounded by glowing screens, the observatory's control room bathed in soft blue light. Outside, the night hums with wind and distance. On your monitor, the data scrolls downward like a heartbeat that's suddenly learned syncopation. It brightens, dims, brightens again, not randomly, but rhythmically, as though it's remembering a song it once knew. Light curves, you think, are supposed to be honest. They tell you everything: rotation, dust, distance, even drama. But 3i Atlas's light doesn't just dim, it flutters. Each pulse feels deliberate, a Morse code tapped out in photons. The first thought that comes to mind is rotation. Comets spin, sure. Their brightness rises and falls as sunlight glances off their surfaces. But this isn't that kind of rhythm. It's too smooth, too consistent, like something engineered rather than eroded. The pattern repeats with uncanny precision, down to the second. It's as if the object is trying to say, "I'm not falling apart, I'm performing." You take a sip of coffee that's been cold since 3 a.m. The taste is bitter, grounding. You adjust the parameters, recheck the instrument alignment. No fault. The telescope is fine. The data's fine. It's the object that isn't. Then the strangest thing happens. The live feed stops. One moment, the signal is flowing perfectly. The next, the screen freezes mid-flicker. A minute later, a system message pops up. Instrument recalibration in progress. You blink. Convenient timing. No one ordered a recalibration. You check the logs. The command came from somewhere upstream from mission control, or maybe from higher still. When you ask, you get polite smiles and vague responses. Just a routine systems check. Funny how the word routine always shows up right when it shouldn't. You imagine the photons still traveling, dutifully bouncing off a body millions of miles away, carrying their tiny packets of truth through the void. While down here, someone hits pause. It's like trying to mute the stars. In the absence of data, rumor fills the vacuum. A few amateur astronomers with backyard telescopes report the same flicker pattern from their observations. 3 seconds bright, 5 seconds dim, repeated like breath. It's steady enough to map, but too faint for them to confirm. NASA dismisses their claims, citing observer error. But you've read their timestamps. They match yours. The pattern continues, then stops, then resumes days later, weaker, slower, like a dying heartbeat fading into space. You find yourself wondering absurd questions. Could it be tumbling? Could something on its surface be moving independently, like panels shifting to catch sunlight? You chuckle at the thought. It's ridiculous, of course. But then again, so is everything about 3i Atlas. You can't shake the feeling that you're watching a performance that someone decided to cancel mid-show. Every time the light curve begins to stabilize, a new technical issue interrupts the feed. The pattern becomes familiar. Brightness rises, data disappears. Brightness fades, data resumes. You joke to a colleague that maybe the object has stage fright. They don't laugh. They just nod, tired, eyes fixed on the static where the signal used to be. Later, in the quiet of the observatory, you pull up old files, snapshots from before the recalibrations. You overlay them. The flicker rhythm forms a repeating interval like a code with structure. A 3-second bright pulse, 5 seconds dim, a pause, then 2 bright peaks in succession. Over and over, you scribble it down, translate the sequence into binary, just for fun. What you get isn't language, but pattern and order that shouldn't exist in something natural. You tell yourself it's coincidence, an artifact of data, smoothing, anything but what your gut suggests. Still, the thought lingers. Light is supposed to wander, not behave. When the next report comes out, it's sterile and exact. Intermittent fluctuations consistent with outgassing activity. Outgassing, another tidy word for cosmic indigestion. But comets that outgas don't blink like light bulbs. They flare, they hiss, they fade unevenly, like campfires, not like metronomes. You wonder if someone, somewhere, saw the same irregular pattern and decided it was better not to explain it. Because if it wasn't gas, if it wasn't spin, then what was it? You lean back, staring at the dark ceiling, tracing constellations in your mind. Maybe the flicker was never a glitch or a flare. Maybe it was an announcement, something old and distant, sending out its coordinates the only way it knew how. Then again, maybe it was just a coincidence, a rhythm in the noise, a trick of numbers and light. The thought comforts you for a moment before the hum of the machines fades into something else, something almost like a pulse. Outside, the stars shimmer above Haleakala, unbothered, unblinking, impossibly steady, and you can't help but notice, none of them flicker like that. Not naturally, anyway. In the quiet, you hear the whisper of your own doubt, soft, rhythmic, steady, a heartbeat, or maybe a countdown. Either way, you know what comes next, because when light begins to stutter, the truth usually follows. Let's glide forward now, into the part of the story where math starts to blush. See, orbital mechanics is supposed to be the adult in the room. No poetry, no personality, just clean numbers doing polite circles around the Sunday. But when 3I Atlas began to drift, ever so slightly, off its predicted course, the math did something deeply uncharacteristic. It raised an eyebrow. At first, the deviation was microscopic. A few arcseconds here, a fraction of a degree there, barely enough to notice unless you were looking for it, which of course, the scientists were. They tracked it night after night, recalculating trajectories like accountants who'd found a missing decimal. And every time they corrected the model, the object politely disagreed. You stare at the data spread across your screen, lines and vectors dancing like notes on invisible staff paper. The orbit is supposed to be a graceful hyperbola, predictable, obedient. Instead, it looks like a jazz solo, mostly structured, but with just enough improvisation to keep Newton awake in his grave. NASA's explanation arrives with the efficiency of a polite email. Solar radiation pressure. Light itself, they say, is pushing the object. It sounds almost poetic, the sun gently blowing cosmic dust across space like dandelion seeds. But the math doesn't sing along. Independent teams run the same calculations and find that for sunlight alone to account for that acceleration, 3I Atlas would have to be impossibly light, like a shadow pretending to be a rock. The object's surface area to mass ratio defies logic. It's too large, too thin, too deliberate. You imagine holding it in your hand if you could, which you can't, and feeling nothing there at all. A structure so delicate it should have crumbled under its own existence. A rock that behaves like foil. A comet that weighs like paper. It's as if the laws of physics are being politely mocked. Of course, NASA doubles down on the solar radiation theory. They even produce a tidy simulation, a 3D rendering of the object drifting gracefully under the sun's gentle breath. It looks reassuringly dull. That's the point. It's designed to tuck the anomaly back under the cosmic rug. But the independent analysts, those curious, sleep-deprived heretics, keep poking holes in the rug. They notice that the object's velocity curve doesn't follow the neat decay expected of solar pressure. It wobbles. It corrects. It compensates. Not in big theatrical ways, but in subtle, almost self-aware nudges. You start thinking absurd thoughts again. Maybe it's hollow. Maybe it's a sail. Maybe it's something ancient, drifting through systems like a bottle through oceans, catching the light of every star it passes. The thought makes you smile, mostly because it's ridiculous, and partly because it's the only one that fits. Still, the official stance holds. NASA says it's natural. The equations say otherwise. Somewhere in the middle lies the truth, balancing like a coin that refuses to fall. You remember that in space, tiny forces add up. A photon here, a particle there, over millions of miles. Even whispers can steer giants. But whispers don't explain intention. Whispers don't explain why the trajectory correction happens before the solar pressure should have reached maximum effect. It's like the object knew the forecast. You imagine the scene in a conference room somewhere. A dozen scientists, half asleep, watching a simulation on loop, while someone in a suit says, "The model's within tolerance." And everyone nods because it's easier than saying, "That thing is flying wrong, and we don't know why." In the background, the universe chuckles softly. Later that night, you run your own back-of-the-envelope estimate. The numbers confirm what you already suspect. For the object's acceleration to match observed data, its density would have to be less than that of air. You laugh out loud. A comet lighter than air. It's absurd, like discovering a brick that floats. You stare at the results again, half expecting them to rearrange into something sensible. They don't. The math is stubborn, like all good witnesses. You imagine 3 Atlas sailing through space, not falling through gravity but surfing it. Its paper-thin surface, shimmering with invisible intent, adjusting course with the precision of something that's done this before. The next morning, a new report appears on NASA's website. It confirms the anomaly, but reframes it. Non-gravitational forces within expected range. The language is so careful, it squeaks. It doesn't deny the deviation, it simply redefines expected. You can't help but admire the elegance of bureaucratic physics. If reality doesn't fit the equation, adjust the definition of normal. Meanwhile, independent observatories keep watching. The object's path continues to deviate, inch by inch, like a shy dancer slowly stepping out of choreography. Each new data point widens the gap between prediction and truth. Eventually, the tracking stops, not because the anomaly ends, but because it drifts too far, too faint, too inconvenient to follow. The official record ends neatly, trajectory consistent with cometary behavior. But in your mind, the path doesn't stop. It keeps bending, curving, whispering something almost playful. Because deep down, you know that in a universe built on precision, nothing ever drifts without reason. And maybe, just maybe, the math wasn't wrong at all. Maybe it was just trying to tell you that something out there isn't falling, it's steering. Let's drift into the part of the story where things start vanishing. Because in space, disappearance isn't silence, it's punctuation. In May 2023, Atlas disintegrated. That's the official phrasing, calm and precise, as though it had politely excused itself from existence. The report said it brightened suddenly, flared magnificently, and then nothing. Not a single confirmed fragment, no debris field, just a convenient phrase slipped into the logs. Fragmentation event. You can almost picture it somewhere in the vast ink of the cosmos, a dot of light growing briefly brilliant, then winking out like a match struck underwater. Telescopes blinked, software updated, and the universe, once again, refused to leave a paper trail. You sit at your screen, replaying the final images frame by frame. One moment, 3i Atlas. Is there a streak of purpose against the dark? The next, it's gone. It's not fading, Not dispersing, just gone. Like someone cut it from the picture with the clean edge of intention. NASA's post-mortem is prompt and polished. The comet underwent spontaneous fragmentation due to thermal stress. A tidy death, wrapped in thermodynamics. But the numbers don't quite behave. The brightness increase before the disappearance doesn't match known fragmentation models. Real comets crumble unevenly, first dimming, then brightening, then scattering light erratically like broken glass. But 3I Atlas? It brightened smoothly, purposefully, and then erased itself with cinematic timing. You scroll through the sequence again, your mind replaying the absurdity of it all. A rock from another star system crosses half the galaxy, survives cosmic radiation, solar heat, and gravitational pinball, only to spontaneously vaporize right when telescopes worldwide are watching. Convenient, isn't it? Independent observatories tried to catch a last glimpse, but by the time their instruments aimed, there was nothing left. No dust plume, no fading tail, no whisper of its trajectory, just silence where something once hummed. You imagine that silence as a kind of smirk, because when an object that shouldn't exist decides to stop existing, it doesn't owe you an explanation. It just leaves. NASA's official graphs flatten like a heart monitor after one last spike. End of observation, they say. And that's it, the cosmic equivalent of case closed. But not everyone agreed. A few quiet voices, tucked in the corners of academic chat threads, started asking questions. What if the flare wasn't a breakup? What if it was propulsion? The idea spreads like static, half joke, half confession. Nobody dares publish it, but everyone thinks it. There's an old rule in astronomy. If something can't be explained naturally, you wait 6 months and call it dust. But 6 months later, no dust ever showed. The region where 3I Atlas was supposed to disintegrate remained oddly clean, as if vacuumed by cosmic housekeeping. Some called it a directional fragmentation, a polite way of saying it left in one piece, just not where we expected. Others whispered about deliberate course correction, a phrase that sounds like science fiction until you realize how often the universe writes like it's auditioning for it. In the quiet hours, you run simulations yourself. You plug in every variable: heat, spin, radiation, mass. Each time, the model predicts debris, streaks, or slow fading. But in every version, 3I Atlas lingers. It refuses to vanish cleanly. The only way for it to disappear without a trace would be for it to change direction fast, precise, controlled. You sit back and exhale. The word controlled feels dangerous in your mouth. Meanwhile, NASA updates its site with one last entry: object no longer visible. The phrasing is almost spiritual. It's not dead, not destroyed, just invisible. Amateur astronomers, stubborn as they are, keep looking. One even posts a faint smear of light online, claiming it's 3I Atlas weeks after the supposed breakup. The coordinates don't match the predicted debris path. NASA dismisses it immediately. Optical error, atmospheric interference, wishful thinking. Maybe they're right. Maybe the human brain just refuses to accept a clean vanishing act. Still, you can't help but imagine it out there, drifting quietly, having faked its own death with professional flair. Somewhere, a fragment, or perhaps the whole still moves, hidden from telescopes, slipping deeper into the dark like a fugitive who knows where the cameras are. You remember something an old astrophysicist once told you over bad coffee. Disappearance in astronomy isn't the end. It's a phase change. Everything that vanishes just learned a better way to hide. And maybe that's what 3I Atlas did. Maybe it didn't die, it evolved. Or maybe it just left because we were watching too closely. You close the data window, The black screen reflects your own face, ghosted in the glass like a reminder that sometimes observation changes the observed. Maybe it didn't vanish at all. Maybe it just learned to look back. Outside, dawn breaks over Haleakala. The light spills across the volcanic ridge, gold and indifferent. The stars fade one by one, like secrets retreating into silence. And somewhere, billions of kilometers away, something that once flickered and flared is still moving, unseen, unbothered, carrying with it the memory of our astonishment. The last entry in the log simply reads, "No further detections." You smile. That's what they said about Oumuamua too. 8. The missing data windows. Let's drift into the part of the story where silence becomes suspicious, where absence itself starts to look like evidence. Between April and May, something strange happened. The official logs for 3I Atlas normally precise down to the millisecond developed gaps. Whole days missing. Not just blank entries, but vanished timestamps, like someone had gone through the digital record with a cosmic eraser. You might not think much of it at first. Data gaps happen all the time. After all, glitches, server errors, telescope downtime. But then you notice the timing. Every missing day corresponds to a spike in brightness, a sudden deviation in trajectory, or most inconveniently, the kind of event NASA tends to file under inconclusive. You open the archives yourself. April 12th, nothing. April 13th, nothing. April 14th, a perfect return to normal. The missing data sits between them like an ellipsis, inviting interpretation. Amateur astronomers across the globe notice it too. Reddit threads sprout overnight. Server issue, says one user. Scrubbed, says another. The difference between error and omission is a matter of trust, and trust, by this point, is running low. Inside the observatory, you picture the data technicians staring at the same void, their screens blinking quietly, waiting for input that will never come. You imagine someone in a cubicle 3 time zones away, sipping cold coffee, clicking delete on a folder marked temporary, backup. Maybe it's nothing, maybe it's protocol, or maybe, just maybe, it's something that didn't fit the script. The strange part isn't that the data's missing, it's that the backups are missing too. NASA's systems are redundant by design. Every observation is mirrored across multiple servers, often in multiple countries. For every lost image, there should be a copy somewhere, but not this time. The log entries for those days don't even reference the existence of data. They've been overwritten by placeholders, lines of code that look neat and harmless. Number data. Sync. Complete. Only the sync never happened. You sit back and breathe. The emptiness of those lines feels heavier than numbers should. Because data doesn't vanish, it's erased. Amateur astronomers start comparing notes. Their backyard telescopes, though limited, caught faint traces on the missing nights. Something large, something bright. One observer in Spain logs a transient light source about the size of Jupiter's apparent diameter, far too large for a comet. He emails NASA. No reply. Another observer in Chile reports the same thing. His post disappears within hours, flagged as unverified. Soon, a whisper moves through the online forums. What if 3I Atlas didn't disintegrate? What if it was eclipsed? The word sends a ripple through the digital cosmos. Eclipsed by what? A passing body? A structure? A shadow that wasn't supposed to be there? You remind yourself to stay rational. Space is full of coincidences, cosmic rays, sensor overloads, calibration bugs. Yet, when you look at the pattern of the missing windows, a chill settles in your stomach. The gaps aren't random. They form a rhythm. Every disappearance lasts almost exactly 36 hours, as if someone had scheduled them. Then comes the maintenance update. A NASA statement appears online, brief and bloodless. Observational interruption due to recalibration of the tracking software. You can almost hear the sigh behind it, the bureaucratic exhaustion of trying to explain away the unexplainable. But those 36-hour silences don't behave like downtime. The observatories kept running. Data from unrelated projects continued uninterrupted. The only stream that went dark was 3I Atlas. You scroll through archived pages of the Atlas project's public portal and notice something eerie. On the days before each blackout, the reported apparent magnitude spikes sharply, meaning it got brighter, suddenly and dramatically. On the day after, it's gone again, dimmer, smaller, as though something had passed in front of it or absorbed part of it. Maybe it's coincidence. Maybe the universe just blinks sometimes. But deep down, you know how rare that is. The cosmos doesn't do convenient timing. The rumor mill churns faster now. A classified satellite observed it up close, says one post. The Air Force took control of the feed, says another. Conspiracy, speculation, paranoia, they multiply like stars in the night. You try to ignore it, but one thread sticks with you. Maybe NASA didn't delete the data. Maybe someone told them to. You laugh softly to yourself, it's absurd. And yet, the logs remain empty. The missing frames never return. The telescope's record resumes after May, perfectly normal again, as if the gap were just a nap in the middle of eternity. But when you overlay the timeline with the trajectory data, you notice one last stubborn inconsistency. The object's projected path after the gap doesn't match where it should have been if it had continued naturally. It's as if the comet, or whatever it was, had jumped, just a fraction of a degree, but enough to matter, enough to suggest movement that wasn't gravitational, enough to whisper the one word every scientist dreads: intentional. You close the screen, the glow fading across your reflection. The silence hums like electricity. Missing data, missing time, missing truth, each one orbiting the other in perfect, suspicious symmetry. And maybe, just maybe, in those vanished days between April and May, the universe blinked, and someone decided we weren't ready to see what it saw. Let's drift into the part of the story where silence becomes suspicious, where absence itself starts to look like evidence. Between April and May, something strange happened. The official logs for 3I Atlas normally precise down to the millisecond developed gaps. Whole days missing, not just blank entries, but vanished timestamps, like someone had gone through the digital record with a cosmic eraser. You might not think much of it at first. Data gaps happen all the time. After all, glitches, server errors, telescope downtime. But then, you notice the timing. Every missing day corresponds to a spike in brightness, a sudden deviation in trajectory, or most inconveniently, the kind of event NASA tends to file under inconclusive. You open the archives yourself. April 12th, nothing. April 13th, nothing. April 14th, a perfect return to normal. The missing data sits between them like an ellipsis, inviting interpretation. Amateur astronomers across the globe notice it too. Reddit threads sprout overnight. Server issue, says one user. Scrubbed, says another. The difference between error and omission is a matter of trust, and trust, by this point, is running low. Inside the observatory, you picture the data technicians staring at the same void, their screens blinking quietly, waiting for input that will never come. You imagine someone in a cubicle 3 time zones away, sipping cold coffee, clicking delete on a folder marked temporary, backup. Maybe it's nothing. Maybe it's protocol. Or maybe, just maybe, it's something that didn't fit the script. The strange part isn't that the data's missing, it's that the backups are missing too. NASA's systems are redundant by design. Every observation is mirrored across multiple servers, often in multiple countries. For every lost image, there should be a copy somewhere, but not this time. The log entries for those days don't even reference the existence of data. They've been overwritten by placeholders, lines of code that look neat and harmless. Number, data, sync, complete. Only the sync never happened. You sit back and breathe. The emptiness of those lines feels heavier than numbers should. Because data doesn't vanish, it's erased. Amateur astronomers start comparing notes. Their backyard telescopes, though limited, caught faint traces on the missing nights. Something large, something bright. One observer in Spain logs a transient light source about the size of Jupiter's apparent diameter, far too large for a comet. He emails NASA. No reply. Another observer in Chile reports the same thing. His post disappears within hours, flagged as unverified. Soon, a whisper moves through the online forums. What if 3i Atlas didn't disintegrate? What if it was eclipsed? The word sends a ripple through the digital cosmos. Eclipsed by what? A passing body? A structure? A shadow that wasn't supposed to be there? You remind yourself to stay rational. Space is full of coincidences, cosmic rays, sensor overloads, calibration bugs. Yet, when you look at the pattern of the missing windows, a chill settles in your stomach. The gaps aren't random. They form a rhythm. Every disappearance lasts almost exactly 36 hours, as if someone had scheduled them. Then comes the maintenance update. A NASA statement appears online, brief and bloodless. Observational interruption due to recalibration of the tracking software. You can almost hear the sigh behind it, the bureaucratic exhaustion of trying to explain away the unexplainable. But those 36-hour silences don't behave like downtime. The observatories kept running. Data from unrelated projects continued uninterrupted. The only stream that went dark was 3i Atlas. You scroll through archived pages of the Atlas project's public portal and notice something eerie. On the days before each blackout, the reported apparent magnitude spikes sharply, meaning it got brighter, suddenly and dramatically. On the day after, it's gone again, dimmer, smaller, as though something had passed in front of it or absorbed part of it. Maybe it's coincidence. Maybe the universe just blinks sometimes. But deep down, you know how rare that is. The cosmos doesn't do convenient timing. The rumor mill churns faster now. A classified satellite observed it up close, says one post. The Air Force took control of the feed, says another. Conspiracy, speculation, paranoia, they multiply like stars in the night. You try to ignore it, but one thread sticks with you. Maybe NASA didn't delete the data. Maybe someone told them to. You laugh softly to yourself, it's absurd. And yet, the logs remain empty. The missing frames never return. The telescope's record resumes after May, perfectly normal again, as if the gap were just a nap in the middle of eternity. But when you overlay the timeline with the trajectory data, you notice one last, stubborn inconsistency. The object's projected path after the gap doesn't match where it should have been if it had continued naturally. It's as if the comet, or whatever it was, had jumped, just a fraction of a degree, but enough to matter, enough to suggest movement that wasn't gravitational, enough to whisper the one word every scientist dreads: intentional. You close the screen, the glow fading across your reflection. The silence hums like electricity, missing data, missing time, missing truth, each one orbiting the other in perfect, suspicious symmetry. And maybe, just maybe, in those vanished days between April and May, the universe blinked and someone decided we weren't ready to see what it saw. Let's step quietly now into the part of the story where the voices that once spoke begin to fade. The scientists behind the discovery of 3I Atlas held one press conference, just one, and then never spoke publicly again. The moment the microphones were turned off, so were the conversations. Interviews were cancelled, emails stopped being returned, and even in academic circles, the topic became something you mentioned only in half sentences, preferably with the door closed. It's odd, isn't it? In science, silence isn't the natural state. Scientists are supposed to argue. They debate, critique, over-explain. Discovery thrives on noise. So when an entire research team falls quiet at the same time, the absence rings louder than words. You picture the scene at that lone press conference. A sterile auditorium, bright lights, a handful of weary researchers in neatly pressed shirts that still smell faintly of burnt coffee and sleepless nights. One of them clears their throat, smiles the way people do when they're trying not to look nervous, and begins, "Thank you all for coming." They talk about light curves and orbital mechanics. They talk about standard procedures, instrument calibration, and the value of international collaboration. They thank the funding agencies. They remind everyone that science is self-correcting, which is another way of saying, we'd rather not speculate. But if you watch closely, you see it the twitch at the corner of a mouth when a journalist asks a question that isn't on the list. The pause before an answer that's been rehearsed, but still feels heavy in the throat. The shift of eyes toward a colleague, as if silently asking, "Do I say it?" And then, the pivot. "It's an exciting time for astronomy," one of them says, steering the discussion back to safer ground. The audience chuckles. Cameras flash. Someone claps too early. And just like that, the conversation ends before it really begins. After that day, the Atlas team evaporates from the spotlight. Their names still appear in databases, but new papers avoid mentioning 3I Atlas altogether. Requests for interviews bounce with polite auto-replies, unavailable for comment. Even in formal talks, those casual conference hallway conversations that usually spill secrets faster than any leak, fall strangely flat. When the topic arises, shoulders tense. People glance around before changing the subject. It's as if the discovery itself became radioactive. Not dangerous, exactly just untouchable. Some call it burnout. The year was heavy, after all, full of world-ending headlines and collapsing conferences. Maybe they were tired. Maybe the politics of space agencies and funding bodies drained the last drop of wonder out of them. That's the kind explanation. But the other one, the one whispered in late-night Slack messages between graduate students who should really be sleeping, feels heavier. Maybe they were told to stop talking. Not in a sinister, cloak and dagger way, but in the polite, bureaucratic tone that hides behind phrases like ongoing review or classified coordination. You imagine one of them sitting at home months later, staring at an unanswered email from a journalist. Their cursor hovers over the reply box. They start to type, "There's something you should know," and then delete it. Because how do you explain what you can't prove? How do you tell the world that the object you tracked wasn't behaving like it should, and then it disappeared? Somewhere, the data still exists. It has to. The raw frames, the calibration files, the tracking logs, they're all stored on servers under names like OBS 202004B. But none of them are public anymore. The links that once worked now return the digital equivalent of a blank stare. Error 404. The silence begins to spread beyond the Atlas team. Partner observatories stop mentioning it. The European Space Agency's updates quietly omit its name. Even Wikipedia's article, once a hive of edits and speculation, freezes in time, locked by moderators due to excessive vandalism. It's strange how quickly collective curiosity can be erased with a few administrative keystrokes. You find yourself scrolling through archived versions of the web, piecing together fragments from before the blackout. There's an interview quote that used to exist. One researcher describing 3I Atlas as peculiar, almost too reflective for a comet. The quote's gone now, replaced by ellipses. It feels like archaeology, this digital excavation sifting through cached pages for fossils of truth. Every deleted line becomes a breadcrumb, every omission another clue, and maybe, in the quiet corners of their minds, the scientists still think about it. Maybe they wake up some nights remembering that flicker on the screen, that deviation in orbit, that moment of awe before the emails arrived telling them to refrain from speculative commentary. Scriptment in 65. Science doesn't erase, it archives. And silence, when it comes from scientists, isn't forgetfulness, it's protection. For reputation, for funding, maybe even for sanity, you close the tab. The hum of your computer fills the room, the digital equivalent of white noise, steady, neutral, loyal. The silence of the Atlas team lingers there, like background radiation, faint, consistent, impossible to remove. And you can't help but wonder what's louder in the universe, the roar of a dying star, or the quiet of a discovery that no one is allowed to talk about. 10. Echoes of artificial origin. Let's move softly now, into the part of the story where science flirts with science fiction and then quickly pretends it didn't. Some physicists, driven by curiosity or caffeine, and probably both, proposed a wild idea. What if 3I Atlas wasn't natural at all? Its odd acceleration, its reflectivity, even the way it disintegrated or seemed to fit better with a thin-shelled structure than with any known comet. Something more like light sail debris, maybe ancient, maybe deliberate. Of course, NASA dismissed the idea instantly. They called it improbable, but not impossible, and that small crack in the door has kept theorists awake ever since. You sit at your desk, staring at side-by-side graphs of 3I Atlas and Oumuamua, two visitors from the stars, both behaving like they'd missed the memo about physics, both strangely reflective, strangely light, and strangely resistant to explanation. If comets are nature's breadcrumbs, these two felt more like forgotten machinery gleaming, weightless, uninvited. One paper, written quietly by an astrophysicist who probably knew it might cost them tenure, suggested the numbers fit a thin sheet of reflective material, only a few millimeters thick, something like solar sail debris, the kind humans are just beginning to design, the kind meant to ride sunlight like a wind current, the kind meant to last. But the problem with suggesting something meant to do anything is that it implies a maker, and the scientific community hates implying intent. Intent belongs to biology, to civilizations, to the kind of questions that end careers. Still, the details are haunting. 3I At. ATLS's albedo, the measure of how much light it reflects, was too high for a dusty comet, but too uneven for bare rock. It shimmered like brushed metal. Its acceleration wasn't explosive, like outgassing, but smooth, gradual, consistent. And the supposed disintegration, it looked more like a burnout, controlled, graceful, as if it shut itself off. NASA's official statement was precise, almost over-polished. There is no evidence to suggest artificial origin, which, of course, isn't the same thing as saying there's evidence it wasn't. You picture the discussion behind closed doors, a round table in a conference room, the kind with no windows and too much fluorescent light. A slide on the screen reads, "Non-gravitational acceleration, anomalous but explainable." A hand goes up. Explainable how? The silence that follows could fill the room. Someone shifts in their seat, someone else clears their throat, and then the conversation detours into public perception management. Because science, for all its courage, still has PR, and the public, they assume, doesn't sleep well when told the cosmos might contain breadcrumbs left by someone else. But curiosity is stubborn. A few rogue researchers start to dig deeper. They note that the observed spin rate of 3I Atlas didn't match what thermal stress would produce. Instead, it oscillated, as if adjusting itself against pressure like a sail tightening against wind. A few even claim that before it vanished, its reflectivity changed in discrete steps, not random fades, almost like panels reorienting. It sounds ridiculous, and yet, so does everything about this story. One of the physicists writes a private note later leaked online. "If this is debris, it's not ours." A quiet sentence buried in an appendix that reads like a confession. It's retracted later, officially labeled out of context. But you can't unsee it once you have. You imagine what it would mean if they were right. An ancient probe, built by someone long gone, wandering interstellar space for millennia. It drifts between stars, weathered and silent, still obeying a program written in a language no one remembers. Every so often, it encounters a system, curves gently around a sun, adjusts course, and keeps going. We wouldn't be the first to send such things, after all. Our own Voyager probes are already sailing outward, each carrying a golden record engraved with a message we'll never hear back from. Perhaps 3I Atlas is someone else's Voyager centuries ahead, or centuries behind. Of course, that's not the official version. The official version fits neatly into PowerPoint slides and budget reports. Comet fragment, solar heating, natural processes, words that reassure, because reassurance is cheaper than rewriting the textbooks. And yet, the phrase improbable, but not impossible, hangs in the air like a spark that refuses to die. You think of it when you look up at the night sky, that thin layer of light stretched between here and everything else. Every star could be a destination. Every flicker could be a traveler. You close your laptop. The screen's reflection lingers for a moment, your own face staring back like a ghost. You whisper the numbers, light, curves, ratios, spin rates, each one a fragment of something bigger, something that might have been more than a rock. Outside, the night sky is vast and quiet. And maybe, just maybe, one of those faint glimmers up there isn't a star at all, but a mirror catching light on its way to nowhere, carrying echoes of an artificial origin we're not yet brave enough to admit. Let's move now into the part of the story where science stops being scientific and starts being strategic. In mid-2021, NASA's proposal board quietly declined a project called the Second Generation Interstellar Object Survey. On paper, it was harmless, just a continuation of the work that spotted 3I Atlas and Oumuamua. More telescopes, better software, and a few dozen scientists who wanted to keep looking for the things that don't belong. But the decision came back, stamped with 6 words that said everything and nothing at once. Overlaps with existing programs. Funding, not approved. The explanation was bureaucratic poetry. Overlaps? With what? The only existing program that even approached interstellar detection was the Atlas network itself, and it wasn't built for deep sky anomalies. That phrase, overlaps with existing programs, was like telling a sailor the ocean was already being studied. Then the emails leaked. Not officially. Of course, nothing ever is. A few lines from internal review correspondence surfaced in forums and private academic chats. One reviewer's comment stood out like a crack in marble. "This topic is politically sensitive at the moment." Another added, "We recommend holding until interagency discussions conclude." The tone was cautious, the language sanitized, but the message was clear. Someone, somewhere, didn't want more telescopes pointed in that direction. You imagine the proposal team reading those lines late at night. After months of drafting and peer review, their project had died not for lack of merit, but because of sensitivity. That word has a special meaning in government: polite, heavy, and non-negotiable. It doesn't mean wrong, it means untouchable. The principal investigator, a seasoned astronomer from Arizona, had spent decades chasing faint objects beyond Neptune. She knew rejection when she saw it, but this one felt rehearsed. The same sentence appeared in multiple review summaries, copied and pasted, as if generated by a template. No one wants to take responsibility for a political no. The safest choice is to let the paperwork decline it for you. A month later, NASA's budget outline included a new section called Strategic Prioritization in Planetary Surveillance. It mentioned improved monitoring for near-Earth asteroids, but not a word about interstellar objects. The timing was immaculate, almost as if the omission were a feature, not a flaw. You start wondering who decides what's politically sensitive in a field that's supposed to study rocks and light. Maybe it's not about aliens or conspiracies. Maybe it's just about control of narrative, control of attention, control of headlines. The agency had already weathered a storm of speculation after 3 IATLAS vanished. Another discovery like that, another set of inconvenient data points, could unravel the carefully repainted story of routine cosmic events. Still, curiosity doesn't freeze as easily as funding. The same scientists whose project was rejected started collaborating unofficially. They used borrowed telescope time, university observatories, even amateur data. One called it backyard cosmology. They joked that they were looking for ghosts with permission from no one. Through their quiet persistence, fragments of correspondence emerged. In one email chain, a program manager asked whether continuing interstellar surveys might invite misinterpretation. Another replied, "Public appetite for mystery remains high. Recommend caution." It's the kind of sentence that tells you everything you need to know about where priorities lie. The researchers didn't push back. They couldn't. Careers depend on grants, and grants depend on diplomacy. In science, the fastest way to lose funding isn't to be wrong, it's to be controversial. So, the project disappeared. Like 3i Atlas itself, the name never appeared again in budget proposals. The phrase interstellar object was quietly replaced with deep trajectory transient. It's a linguistic trick. Change the term, and the topic becomes less noticeable in search results. The silence that follows isn't censorship, it's camouflage. You picture the proposal binder still sitting on a shelf somewhere in NASA HQ, its pages yellowing under fluorescent light. A summary page that begins, "With the detection of 2 confirmed interstellar visitors, it is imperative we establish a dedicated long-term survey system," and ends, in red pen, "Declined." Redundant to existing observation strategy. Maybe that's the real tragedy of bureaucracy. It doesn't need villains or secrets, just paperwork thick enough to bury wonder. Still, the rejection left ripples. The amateur community noticed the gap in funding, and independent foundations started offering grants of their own. A few small observatories in Chile and South Africa now track fast-moving objects under private initiatives. They call themselves the Post-Atlas Network. It's science by stubbornness, a rebellion conducted with spreadsheets and starlight. Meanwhile, NASA's official stance remains calm and practiced. When asked about interstellar detection funding, their spokesperson said, "We continue to evaluate resource allocation within established mission parameters." That's bureaucrat for, "We're not touching that again." Maybe it's just politics. Maybe it's fatigue. Or maybe the agency that once looked outward decided that some things are safer left unobserved. Because sometimes, the easiest way to hide a mystery isn't to erase it. It's to stop paying for the telescope. Let's drift into the part of the story where sunlight itself becomes the engine. To move without engines, you need only light. That's the idea behind a solar sail. A vast, thin sheet that rides the pressure of photons the way a ship rides wind. No thrust, no exhaust. Just radiation pressure, steady as a breeze that never stops blowing. It sounds like poetry dressed as physics. But for 3i Atlas, the math didn't just hint at it. It fit, almost perfectly. At first, it seemed like another anomaly in a long list of anomalies. The object was moving too fast, drifting too lightly, refusing to obey the standard gravitational script. But when researchers plotted its acceleration against the intensity of solar radiation, the curve snapped into alignment like a puzzle piece clicking into place. It wasn't random. It wasn't chaotic. It was consistent with something responding to light precisely, predictably, deliberately. In NASA's internal modeling software, a single variable describes that kind of motion, sail-like behavior. The label appeared briefly in an early draft report, buried deep in metadata that wasn't meant for public release. A week later, the tag vanished. The report was republished with one word changed: non-gravitational acceleration. The universe hadn't changed, but the vocabulary had. You imagine the meeting that followed, a conference call between engineers, physicists, and public affairs officers. Someone clears their throat and says, "We can't use the term sail-like. It invites interpretation." Someone else agrees. Interpretation is dangerous. Safer, to let it sound like math again, but you can't suppress the physics. Sunlight, though weightless, carries momentum. When it hits a reflective surface, it imparts a tiny push, a pressure so faint it could barely move a feather on Earth, yet enough to guide a sheet of foil through the void. The Japanese spacecraft Ikaros proved it in 2010, unfurling a gossamer sail in space and drifting serenely under the sun's breath. LightSail 2 did it again in 2019. Humanity has only just begun to play with this technology. The cosmos, it seems, might have been using it for a while. If 3i Atlas was natural, it was the most conveniently aerodynamic rock in history. To behave as it did, it would need to be extraordinarily thin, mere millimeters across, like the skin of a whisper, and yet strong enough to survive interstellar travel. Nature doesn't tend to build things like that, not without a little help. The reflection data didn't help NASA's cause either. The object's surface shimmered inconsistently, its brightness rising and falling, not like dust scattering light, but like something smooth and metallic, catching the sun at precise angles. At times, it reflected more light than it should have been physically capable of, as if parts of its surface had changed orientation. The astrophysical term for that is non-isotropic reflectance. The human term is it turned itself. Of course, that sounds absurd. A comet doesn't turn itself. Rocks don't adjust course, but equations don't care about absurdity. They care about numbers, and the numbers whispered, "This thing sails." You can almost feel the unease among the data analysts who saw it first. Late night messages. "Are you seeing this? Try rerunning the parameters. It can't be that clean." Every test led back to the same result. Too light, too reflective, too engineered. The next step would have been to publish. But how do you write a paper that says, "The universe may have just mailed us a mirror"? You can't. So instead, they reframed it. The final reports mention non-gravitational acceleration, consistent with radiation pressure. That's bureaucratic poetry for, "We have no idea, but please don't ask about sales." Still, the evidence lingers in the margins. In one internal model, before edits, a line of code remains sail. Flag equals true. It's commented out, as if embarrassed to exist. But computers, unlike people, don't lie. They simply record. You picture 3I Atlas drifting now through the darkness, its paper-thin body shimmering in starlight, adjusting its angle subtly, like a dancer responding to invisible music. Maybe it was built. Maybe it wasn't. Maybe nature, in her endless inventiveness, decided to experiment with geometry we don't yet understand. But part of you suspects something older, something designed, forgotten, or abandoned. A relic-riding photon winds from star to star, powered by nothing but the memory of light. NASA eventually scrubbed the sail-like reference from all public databases. A harmless housekeeping update, they said. Just formatting. But the timing immediately after the object's final disappearance feels less like formatting and more like closure. You lean back, eyes closed, and imagine sunlight as an ocean, every beam a current. And somewhere out there, a vessel we didn't build catches the wind and drifts on, patient, ancient, and completely indifferent to the names we give it. Let's step now into the part of the story where color itself becomes controversial, where the light that reaches our telescopes whispers something that official reports later forget to mention. Every object in the universe reflects a signature, a fingerprint made of color and chemistry, called a spectrum. And for one brief observation window, 3I Atlas revealed something peculiar, a dip near 3.4 microns, a wavelength humans know very well because it belongs not to rocks or ice, but to us. You probably encounter it every day, though you'd never notice. That same 3.4 micron absorption appears in synthetic polymers, plastics, and industrial coatings. It's what light looks like when it bounces off something that's been manufactured. The astronomers who first saw it didn't shout. They squinted. The dip was small, subtle, almost easy to ignore, but it was there, consistent, repeating, unmistakable. A signature of carbon-hydrogen bonds in a configuration nature doesn't normally bother to make in comets or dust. For a moment, just one shimmering moment, 3I Atlas looked less like a rock from another system and more like packaging. The spectrum data appeared briefly on NASA's servers, part of a routine upload from the infrared telescope facility in Mauna Kea. It wasn't headline stuff, just a set of calibration curves, hidden in a downloadable zip file with a name only a scientist could love. For a few hours, it was accessible to anyone who knew where to look. And then, quietly, it was gone. The next day, the file was replaced. Same title, different contents. The entry for the 3.4 micron range now showed data not available due to interference. The justification sounded plausible. Instrumental noise, sensor, contamination, cosmic rays. The universe is messy, after all. But what made the omission suspicious wasn't the deletion itself. It was that no other wavelengths were affected. You imagine the analysts staring at the graphs that night. The dip, so clean, so sharp, that even if it were noise, it was beautiful noise. One of them probably said, "That looks synthetic," and someone else probably said, "Don't say that again." Spectroscopy isn't glamorous. It's rows of numbers, peaks and valleys, a slow translation of light into chemistry. But hidden inside those squiggles are the fingerprints of everything: metals, minerals, atmospheres, even civilizations. If a planet full of cities were reflecting sunlight toward us, we could, in theory, see the ghost of its plastics in its spectrum. That's the thing about light. It tattles. And so, if 3I Atlas really did carry that 3.4 micron dip, then it wasn't just a rock. It was a message made of reflected truth. NASA's next public release contained no mention of spectroscopy. They focused on trajectory, spin, and reflectivity. One paragraph even said, "No unusual spectral features were observed." It was definitive, direct, and absolutely untrue, because at least one telescope had seen something very unusual indeed. Later, an independent researcher at the University of Toronto tried to reconstruct the missing data set using partial telemetry logs. They managed to recreate the curve, and there it was again, faint but stubborn, like a fingerprint left behind after someone tried to wipe it away. They published the finding on a small personal blog with the title, "An Anomaly at 3.4. 2 weeks later, the post was gone. Server error. You begin to notice a pattern. Whenever something about 3I Atlas points toward manufactured, the data evaporates. When it behaves naturally, the data multiplies. The universe, apparently, only gets to be weird when it's convenient. Still, you can't stop picturing that signature, a narrow dip in the infrared spectrum, a whisper of something once shaped by purpose. You wonder what it might have looked like up close: a fragment of foil, a honeycomb of polymer, aging quietly in starlight, something built to last 1,000 years, drifting through systems like a lost page from someone else's history. Some skeptics argue that organic's complex carbon compounds can form similar features naturally. They're right. Nature can imitate almost anything, given enough time. But the pattern of that dip wasn't random. It aligned too neatly, too sharply, like a barcode waiting to be scanned. If the data were still accessible, someone might have cross-checked it, confirmed or debunked it. But it's gone now, buried beneath instrument interference. The safest phrase in science, a way of saying we saw something we can't explain, so let's pretend we didn't. You lean back and imagine the faint hum of that lost signal, photons that traveled millions of miles to reach us, only to be filtered by both atmosphere and bureaucracy. Somewhere in that missing range of color, maybe there was truth, one small dip that didn't fit the story. And maybe that's why it had to disappear. After all, if the light we catch from a stranger among the stars starts looking a little too familiar, if it carries the fingerprints of our own inventions, then the question isn't just what we saw, it's who left it behind. Let's step carefully now into the part of the story where discovery meets the oldest force in academia: disappearance by deletion. A paper appeared, briefly, analyzing those strange spectral lines from 3I Atlas. It wasn't dramatic, not at first glance, just a quiet preprint, co-authored by 2 graduate students, one from Chile, one from Japan. The kind of paper that usually gets maybe 12 downloads and 1 polite email. Except, This one didn't fade into obscurity. It vanished. Less than a week after upload, the preprint was gone from the archive. No retraction notice, no explanation, just an empty link where science used to be. You can almost imagine the moment they hit submit, the hum of the campus server room, the email confirmation pinging softly at 2 a.m. The quiet triumph of two young researchers seeing their names in a citation format for the first time. It must have felt electric, a footnote in the history of something bigger, and then, within days, it was gone. The file's cached version lasted a little longer, long enough for a few sleepless readers to download it. Those fragments told a strange story. The students had found an absorption feature at 3.4 microns, just like others had whispered about, and proposed cautiously, nervously, that it resembled polymer residues. They didn't say artificial. They didn't say alien. They said non-natural configuration. It was careful language, the kind you use when you're still hoping the data will protect you. But in science, the word non-natural can be a landmine. Within 72 hours, the archive's moderators marked the paper as temporarily removed pending review. That phrase usually means a formatting issue or duplicate submission, but no updated version ever reappeared. The author's institutional pages went quiet too. No updates, no new projects. Their social media accounts, once active with photos of observatories and late-night code jokes, fell silent. When a journalist emailed one of them months later, the reply came short and careful. We were advised to move on. Nothing else. No bitterness. No elaboration. Just the digital equivalent of a closed door. You sit back, staring at that phrase. Advised to move on. It's the perfect sentence. Gentle, professional, suffocating. It doesn't mean wrong. It means inconvenient. In academic circles, everyone understands the choreography. You discover something you shouldn't, and suddenly your advisor reminds you about career focus. The department chair suggests you prioritize publishable work. A funding partner withdraws, pending clarification. It's not censorship, not technically. It's just an avalanche of reasons to be quiet. You imagine their meetings in those final days before the upload vanished. Two exhausted grad students staring at the screen, their supervisor pacing behind them. Are you sure about that word? They ask. Maybe use anomalous instead of non-natural. But the data won't change its mind. The numbers keep whispering the same shape. Too clean, too sharp, too human-made. Then the email comes. Probably from someone higher up, polite, distant, written in the careful tone of bureaucracy. After internal consultation, we recommend removing the submission until further validation. A sentence so soft it almost sounds like permission, but everyone knows it's not. The story spreads in fragments, whispers in astronomy forums, screenshots of the missing citation, an archived DOI number with no paper attached. Some claim to have read it, others say it never existed. One Reddit user insists they downloaded it, and then their file corrupted. Whether true or not, the myth grows teeth. And it isn't just the students who vanish. A senior scientist who informally reviewed their draft later removes his name from several related projects. In an unrelated interview about exoplanet spectroscopy, when asked about 3I Atlas, he smiles too quickly and says, "That was an interesting time," then changes the subject. It's funny how the universe can be endless, but the space for curiosity can feel so small. Officially, the deletion is explained as a data calibration error. The archive lists it under withdrawn for quality assurance, but even that phrasing rings hollow. The file's checksum, The digital fingerprint that proves a document existed remains in the record. It's there, ghost-like, testifying that something once occupied that space. You imagine the students now. Maybe they're still in astronomy, quietly working on safer things, dust models, orbital dynamics, grant-friendly research. Maybe they still think about that missing spectrum, about the faint dip at 3.4 microns that dared to look industrial. Maybe they keep a printout in a drawer somewhere, just to remind themselves that for one small moment, they glimpsed something bigger than a career. Science prides itself on transparency, but sometimes it acts like an eclipse. Something bright gets in the way, and everything behind it goes dark. The missing paper is a tiny event, a single pixel in the grand image of discovery. But in that pixel lies the whole mystery of 3I Atlas, a truth too fragile, or too dangerous, or maybe too absurd to survive the weight of official approval. You close your laptop and stare into the darkness outside. Somewhere, far beyond the reach of telescopes, something might still be reflecting our light back at us, unbothered, unchanged, and entirely real, no matter how many papers disappear trying to describe it. Let's step into the part of the story where the universe doesn't just keep secrets, it files them under routine. In the grand ledger of celestial anomalies, few phrases are as convenient as cometary fragmentation. It's the cosmic equivalent of saying, "It just broke." A flare, a fade, a mystery solved. No paperwork required. When 3I Atlas vanished, that was the line NASA offered to the world. Fragmentation event, they said. Calm and clinical. It explained everything, and therefore nothing. A brightening, debris, a disappearance, evaporation, a data gap, instrument noise. The story folded neatly back into the expected pattern. Comet flares, comet dies, case closed. You sit at your desk, scrolling through the light curve graphs, each one a heartbeat of brightness plotted against time. The final days should show chaos, peaks and troughs, shards scattering light unevenly. Instead, the curve is elegant, smooth, almost musical. It doesn't collapse like a dying body. It tightens like a pirouette. Disintegration, by its nature, is messy. But 3I Atlas didn't flicker out, it spun up. The last few hours of data show something rotating faster, not falling apart. You can almost feel it in the numbers. The acceleration of light bouncing off its surface, like a dancer gathering speed before bowing out. You imagine the meeting where this was first noticed. A handful of scientists, coffee-stained notebooks open, watching the model output climb into implausibility. Someone says, "That's not fragmentation." Another mutters, "It's rotation." Then, silence, because rotation raises questions, but fragmentation ends them. The press release wrote itself. Thermal stress exceeded cohesion limits. Perfectly reasonable. The sun's heat, the vacuum's pull, any fragile object would crumble. It's a comfortingly human story. Even comets get overwhelmed sometimes. But there's one problem. No fragments were ever found. None. Not one speck detected in the predicted debris cloud. The region of sky, where telescopes expected to see glittering remnants, remained stubbornly clean. It's as if the universe itself agreed to the cover story. Astronomers are used to things breaking. That's what space does best. But they're not used to clean exits. Dust doesn't just vanish. It scatters, drifts, lingers, like cosmic dandruff. Yet the sensors saw nothing, no lingering tail, no expanding debris sphere, just absence. A few independent teams tried to model the light curve differently. One fit produced an unnerving result. The brightness matched a reflective surface, changing orientation, not one losing mass. In other words, it looked less like an explosion and more like someone turning a mirror. You picture 3I Atlas spinning slowly at first, then faster, aligning itself with sunlight as it prepares to disappear from view. Not destroyed, just out of sight, like a satellite executing one last maneuver before powering down. It's absurd, of course, or at least that's what you tell yourself. But the math doesn't care what's absurd. The math just fits. NASA's official language avoids contradiction by avoiding precision. Observed fragmentation, consistent with thermal disruption. That phrase is a masterpiece of ambiguity. It doesn't say what happened. It says what could have happened, under conditions no one can verify anymore. Meanwhile, a few quiet skeptics continue to whisper. One paper buried in a small journal from Eastern Europe notes that if 3I Atlas truly broke apart, the energy released would have produced a secondary flare 10 times brighter than what was observed. It didn't. The brightness spiked modestly, then stabilized, like something conserving power. Another researcher, anonymously quoted in a forum, put it bluntly, "The numbers say it spun itself invisible." You find yourself smiling at that phrase. It sounds like poetry, disguised as physics. Spun itself invisible. The kind of sentence that belongs in folklore, not technical reports. And yet here it is, written in the margins of a universe that refuses to make sense politely. If 3I Atlas really did fragment, then nature broke her own rules, to do it cleanly, silently, efficiently. No shards, no dust, just light fading with perfect composure. And if it didn't, then something else happened, something quieter, more deliberate. Maybe the flare wasn't a death rattle but a signal. Maybe what we saw wasn't an ending but an exit. The irony is that cometary fragmentation was never meant to deceive anyone. It's simply a reflex, a way for science to close drawers it can't yet label. When you work long enough in uncertainty, you start to crave tidy words, even if they hide messy truths. You close the case file in your mind. Fragmentation. The word feels hollow now, like a curtain covering an empty stage. Outside, the night sky glows faintly through your window. Millions of stars, billions of stories, each one ending the same way. It broke apart. But maybe not everything does. Maybe some things just leave gracefully, intentionally, unseen, taking their secrets with them into the dark. Let's step now into the part of the story where the plot thickens quietly, bureaucratically, with a PDF. Around the same time that 3I Atlas supposedly broke apart, NASA's Planetary Defense Coordination Office, the team in charge of keeping Earth safe from things that fall out of the sky, made a small, silent edit to its protocols. No fanfare, no press release, just a line added to a government document. New parameters for unclassified interstellar near-Earth objects. The change was subtle, buried deep inside the document's appendix. You wouldn't notice it unless you'd memorized the previous version, which, of course, some people had. Amateur watchdogs, retired engineers, the kind of dedicated souls who read PDFs like bedtime stories. And they did notice. In earlier editions, the wording referred only to comets and asteroids of solar system origin. But in the 2020 update, a new category appeared. One that didn't exist before. Non-native interstellar transients. A sterile phrase, but it meant something extraordinary. NASA had quietly built a box for things like 3I Atlas. You can imagine the internal memo that preceded it. Subject line: classification refinement for extrastellar bodies. Harmless, clinical, bureaucratically boring. The best kind of camouflage. But behind that wording sits a truth that makes even the most cautious administrator sweat. Once is coincidence, twice is precedent. Because 3I Atlas wasn't the first, Oumuamua had already forced NASA and the IAU to invent new categories: first interstellar asteroid, then interstellar object. Now, with 3I Atlas, they were tightening definitions, creating new branches in their own defensive playbook. You don't add new threat classifications for fun. You do it when something has made you uncomfortable. The public never heard about the update. The file was uploaded to an obscure government server on a Friday evening when no one was watching. No press release, no social media post, not even a quiet newsroom mention. Just a timestamp and a metadata note. Version 5.3 replaces 5.2. A few internet sleuths found it weeks later and started connecting dots that probably shouldn't have been connected. The timing aligned perfectly with 3I Atlas's fragmentation event. Within days of the comet's disappearance, NASA added procedures for non-gravitational anomalies and unverified disintegration reports. A polite way of saying, sometimes things vanish, and we should know what to do when they do. The term unclassified stood out too. In government speak, that word doesn't always mean free to share. It often means a classified version exists elsewhere. You can picture the staff meeting at the Planetary Defense Office that week. The fluorescent hum, the coffee cups, the tired expressions. Someone opens the agenda. Slide bullet point 3. Interstellar. Object response framework. The phrase sounds grand, but the discussion is likely anything but. Should we include it under natural hazard response or contingency awareness? Someone asks. Better make a new category, another replies. Just in case. Just in case what? The PDF itself is a marvel of understatement. Page 114, Section C. Unclassified interstellar objects may exhibit atypical acceleration or luminosity behavior. Observations should be logged under anomalous transient phenomena with appropriate flagging. Bespile to 9, flagging. It's such an innocent word. Of course, the next question is, why planetary defense? Comets aren't the kind of thing you defend against. You monitor them. You model them. You publish about them. Defense is for threats. Defense is for things that might come back. Maybe that's why no one talked about the update. Because no one wanted to explain what they were preparing for. You scroll through the PDF yourself, comparing versions. The differences are almost poetic, small enough to be deniable, large enough to matter. Extraterrestrial becomes interstellar. Detection and response becomes detection and contingency. Language evolving under pressure, bending around the weight of something it's not allowed to name. Then you reach the final footnote, the one that didn't exist before. In cases where observational gaps coincide with anomalous kinematic behavior, internal review must be expedited before public disclosure. You lean back and let that sentence sink in. It's the rulebook version of, if it moves weird, stop talking about it. The timing is uncanny. The update went live on the 5th of May, 2020, exactly 2 days after 3I Atlas's final observation window closed. Coincidence? Maybe. But if you've learned anything from this story, it's that coincidences tend to happen on schedule. The edit went unnoticed by mainstream media. It didn't need to make headlines. It wasn't written for the public. It was written for the people who would see something strange in the data and need a reminder. There's a procedure for this now. And maybe that's the strangest part, because the quietest changes are often the most revealing. You don't rewrite a planetary defense protocol because of curiosity. You do it because something out there reminded you that the sky doesn't always play by the rules. And perhaps, somewhere in a secure conference room, someone clicked, save as version 5.3, closed their laptop, and thought, just for a second, what if it wasn't a comet at all? Let's move now into the part of the story where the truth isn't deleted, it's quietly rewritten. If you dig deep enough into NASA's online archives, beneath the calm surface of their press releases and the neat precision of their PDFs, you find a strange kind of archaeology. Revisions, tiny, bureaucratic edits to old web pages, changes so small they could only matter if someone wanted them not to. Once, those pages referred to 3I Atlas as an object of unusual composition, harmless, descriptive, accurate. But a few months later, the wording changed. Standard cometary type. The difference looks trivial, one adjective swapped for another, but in science, adjectives are evidence. They are fingerprints, and fingerprints get wiped. You wouldn't notice it if you weren't looking, but someone was. A handful of digital sleuths began tracking the edits across NASA's content management system, comparing snapshots stored by the Wayback Machine. The pattern emerged like a watermark. Edits clustered around the same week the fragmentation announcement was made. And here's where it gets stranger. The metadata timestamps remain. You can see the edits, the exact times, the usernames, redacted, and the log entries. Updated for consistency, modified to reflect consensus. The kind of phrases that sound routine until you realize they were used on a public archive of scientific data. Someone, somewhere, was tidying history. You scroll through the revisions yourself, each one a small act of narrative control. Unusual composition becomes cometry. Non-gravitational acceleration becomes solar radiation influence. Object becomes body. The language shifts subtly toward comfort, like a nervous speaker editing their own tone, mid-sentence. This isn't conspiracy, it's maintenance. Bureaucracies hate ambiguity. They crave clean lines, uniform categories, a world that can be indexed and searched without raising eyebrows. A visitor from beyond the stars that refuses to behave like a comet? That's messy. That invites questions. Better, to make it sound familiar. And yet, the original versions still echo through cached files and archived API snapshots. Data doesn't really die. It lingers in backups, mirrors, and forgotten servers. You can still find traces of the old descriptions if you dig far enough into the subdirectories. In one, there's even a comment tag left behind in the code, is less than. Object classified as unusual, pending further review, is greater than. The tag is dated the 28th of April, 2020. The next day's update deletes it entirely. Maybe it's coincidence. Maybe an intern just followed orders. Maybe someone simply wanted stylistic consistency across pages. But the pattern repeats on at least 8 documents. One line altered, timestamp identical across systems, implying batch editing. That's not random. That's a directive. You picture the meeting that preceded it. A quiet room. The glow of monitors. Someone from communications. Someone from the science team. Someone from legal. A spreadsheet of terms on the screen. One by one, they change unusual to typical, anomalous to nominal, unverified to inconclusive. The goal isn't to lie, it's to settle. Language becomes a kind of containment field. If you can make something sound ordinary long enough, the public stops asking whether it isn't. But metadata has a stubborn memory. You can see the fingerprints of the edits, the timestamps, the hash mismatches, even the server IDs where the changes originated. It's like finding tiny ripples in otherwise calm water. Each edit says, quietly, "We were nervous about this." NASA, of course, never comments on internal revisions. Their official stance is that minor content updates are routine housekeeping. And in most cases, that's true. But when routine housekeeping happens in the middle of an anomaly, and specifically targets every reference to that anomaly, it begins to feel less like cleaning and more like erasure with style. You start wondering who noticed first. Probably not journalists, they rarely dig into page revisions. More likely it was an astrophysics hobbyist, the kind of person who compares checksum values for fun, the kind of person who can spot a single byte change and hear the story it's trying not to tell. A few of them did post their findings online, side-by-side screenshots of the edits, annotated with arrows and timestamps. One Reddit thread even joked, "NASA's version control has better plot twists than Netflix." It went viral for a few hours, then disappeared, flagged for inaccurate content. And yet, here you are, staring at those same edits, still visible in cached copies. The digital fossils of a moment when the narrative blinked. Maybe the truth isn't that NASA was hiding anything malicious. Maybe it's simpler and sadder. Maybe someone thought the world wasn't ready to handle a story that didn't fit the tidy categories of comet, asteroid, or debris. Maybe they thought people sleep better when space behaves, so they cleaned the words. They swept the floor of the archives, tucked away the anomalies, and hoped no one would check the logs. But light, data, and truth all share one trait: they leave residue. Even when rewritten, the echoes remain, and in those echoes, you can still read the story the edits tried to smooth away. Once upon a time, something out there was called unusual. Then someone decided it wasn't. Let's drift now into the part of the story where coincidence and imagination shake hands and then refuse to let go. Some conspiracy theorists claim that Atlas wasn't just the name of a telescope. They insist it was a code name: atmospheric tracking and luminous anomaly surveillance. A mouthful, yes, but catchy enough to stick. There's no proof, of course, just the uneasy way coincidences tend to look like choreography when you're tired and the data doesn't add up. Atlas, officially, stands for Asteroid Terrestrial Impact Last Alert System. It's a real, very unexciting program. 2 telescopes in Hawaii, scanning the skies for objects that might hit Earth. The name fits perfectly, like most NASA acronyms do. But when 3i Atlas appeared, the name took on an irony that conspiracy forums couldn't resist. The very system designed to give us a last alert had discovered an object that came from outside the solar system, and then mysteriously broke apart. You can't make better symbolism if you try. Soon, threads began popping up on Reddit and Twitter. Atlas isn't what they say. Someone claimed to have found a declassified Air Force memo using the phrase luminous anomaly tracking. Someone else pointed out that NASA loves to bury real meanings in acronyms: Apollo, Orion, even the curious phrasing of planetary defense. Before long, the story metastasized. Atlas wasn't a telescope, it was an operation. The myth grew fast because it was elegant. It solved everything. If the data gaps, the silence, the reworded pages, and the missing fragments were all part of a surveillance initiative, then nothing was random. Everything was protocol. You picture how it might have started. One bored hobbyist, scrolling through government procurement listings at 3 a.m., sees an entry labeled Atlas Initiative Phase 2. He Googles it, finds both the telescope and the myth, and decides the overlap isn't coincidence. He posts his discovery with a dramatic headline: "Proof NASA's hiding something. Atlas is a cover name." It spreads like wildfire. Within a week, YouTube thumbnails start screaming in all caps: NASA's secret project revealed. The truth, as usual, is quieter and infinitely duller. The word Atlas shows up everywhere in aerospace because scientists like themes. There's an Atlas experiment at CERN, an Atlas V rocket, even a DARPA system called Atlas for terrain analysis. It's practically the Bob of acronyms. But once a myth has rhythm, logic doesn't matter. NASA tries, half-heartedly, to clarify. Their official site posts a single line: Atlas is a civilian-operated asteroid survey. It reads like an adult, reminding a roomful of children that Santa isn't real. But by then, the damage is done. The codename theory becomes self-sustaining. And to be fair, NASA doesn't help itself. The agency's communication style is famously allergic to transparency. When it hides something, even something as harmless as a software glitch, it does it so awkwardly that it looks like espionage. Silence, in a vacuum, sounds like confession. The forums pick up on this, of course. They start dissecting the phrase, luminous anomaly. What counts as luminous? What counts as anomalous? Could 3i Atlas itself be the anomaly being tracked? The internet loves recursive mysteries. A project named Atlas, studying an object named 3i Atlas. It's almost poetic. Too poetic to be an accident, they argue. You scroll through those threads, equal parts amused and uneasy. The posts range from half-baked theories about cosmic surveillance drones to oddly professional analyses quoting orbital mechanics textbooks. One user even uploads a mock logo: Atlas, atmospheric tracking, and luminous anomaly surveillance, with the NASA swoosh beneath it. It looks real enough that even you pause for a moment before remembering it's a joke. But jokes become folklore when the world refuses to clarify itself. And soon, the codename myth takes on a life of its own. People begin finding evidence everywhere: blurred objects in old satellite photos, unexplained telemetry spikes, contract numbers that happen to start with 3, 1AT, LAS. The human brain is built for patterns. Give it chaos, and it will stitch meaning from the void. Still, part of you can't shake the symmetry of it. Atmospheric tracking and luminous anomaly surveillance. It fits too well. If it's coincidence, it's the kind the universe seems to enjoy just plausible enough to whisper instead of shout. And perhaps that's why the myth endures. It doesn't need to be true. It just needs to sound like something that could be. The world feels bigger, stranger, more connected when secrets hide behind ordinary names. It gives us the comforting illusion that someone, somewhere, knows what's really going on. Maybe the truth is exactly what NASA says. Atlas is just a telescope, a brilliant, hard-working system designed to warn us when rocks are coming. Or maybe the acronym's double meaning is just one of those little cosmic jokes, an inside pun between humans and the sky. Either way, the myth serves a purpose. It reminds you how easy it is to mistake silence for secrecy and coincidence for code. And maybe that's the lesson here. Every great mystery starts with someone noticing something too symmetrical to ignore and deciding that symmetry means design. Let's move now into the part of the story where silence stops being scientific and starts being strategic. In mid-2021, NASA's proposal board quietly declined a project called the Second Generation Interstellar Object Survey. On paper, it was harmless, just a continuation of the work that spotted 3i Atlas and Oumuamua. More telescopes, better software, and a few dozen scientists who wanted to keep looking for the things that don't belong. But the decision came back, stamped with 6 words that said everything and nothing at once. Overlaps with existing programs. Funding not approved. The explanation was bureaucratic poetry. Overlaps? With what? The only existing program that even approached interstellar detection was the Atlas network itself, and it wasn't built for deep sky anomalies. That phrase, overlaps with existing programs, was like telling a sailor the ocean was already being studied. Then the emails leaked. Not officially. Of course, nothing ever is. A few lines from internal review correspondence surfaced in forums and private academic chats. One reviewer's comment stood out like a crack in marble. "This topic is politically sensitive at the moment." Another added, "We recommend holding until interagency discussions conclude." The tone was cautious, the language sanitized, but the message was clear. Someone, somewhere, didn't want more telescopes pointed in that direction. You imagine the proposal team reading those lines late at night. After months of drafting and peer review, their project had died not for lack of merit, but because of sensitivity. That word has a special meaning in government: polite, heavy, and non-negotiable. It doesn't mean wrong, it means untouchable. The principal investigator, a seasoned astronomer from Arizona, had spent decades chasing faint objects beyond Neptune. She knew rejection when she saw it, but this one felt rehearsed. The same sentence appeared in multiple review summaries, copied and pasted, as if generated by a template. No one wants to take responsibility for a political no. The safest choice is to let the paperwork decline it for you. A month later, NASA's budget outline included a new section called Strategic Prioritization in Planetary Surveillance. It mentioned improved monitoring for near-Earth asteroids, but not a word about interstellar objects. The timing was immaculate, almost as if the omission were a feature, not a flaw. You start wondering who decides what's politically sensitive in a field that's supposed to study rocks and light. Maybe it's not about aliens or conspiracies. Maybe it's just about control. Control of narrative, control of attention, control of headlines. The agency had already weathered a storm of speculation after 3 IATLAS vanished. Another discovery like that, another set of inconvenient data points, could unravel the carefully repainted story of routine cosmic events. Still, curiosity doesn't freeze as easily as funding. The same scientists whose project was rejected started collaborating unofficially. They used borrowed telescope time, university observatories, even amateur data. One called it backyard cosmology. They joked that they were looking for ghosts with permission from no one. Through their quiet persistence, fragments of correspondence emerged. In one email chain, a program manager asked whether continuing interstellar surveys might invite misinterpretation. Another replied, "Public appetite for mystery remains high. Recommend caution." It's the kind of sentence that tells you everything you need to know about where priorities lie. The researchers didn't push back. They couldn't. Careers depend on grants, and grants depend on diplomacy. In science, the fastest way to lose funding isn't to be wrong, it's to be controversial. So, the project disappeared. Like 3i Atlas itself, the name never appeared again in budget proposals. The phrase interstellar object was quietly replaced with deep trajectory transient. It's a linguistic trick. Change the term, and the topic becomes less noticeable in search results. The silence that follows isn't censorship. It's camouflage. You picture the proposal binder still sitting on a shelf somewhere in NASA HQ, its pages yellowing under fluorescent light. A summary page that begins, "With the detection of 2 confirmed interstellar visitors, it is imperative we establish a dedicated long-term survey system," and ends, in red pen, "Declined." Redundant to existing observation strategy. Maybe that's the real tragedy of bureaucracy. It doesn't need villains or secrets, just paperwork thick enough to bury wonder. Still, the rejection left ripples. The amateur community noticed the gap in funding, and independent foundations started offering grants of their own. A few small observatories in Chile and South Africa now track fast-moving objects under private initiatives. They call themselves the Post-Atlas Network. It's science by stubbornness, a rebellion conducted with spreadsheets and starlight. Meanwhile, NASA's official stance remains calm and practiced. When asked about interstellar detection funding, their spokesperson said, "We continue to evaluate resource allocation within established mission parameters." That's bureaucrat for, "We're not touching that again." Maybe it's just politics. Maybe it's fatigue. Or maybe the agency that once looked outward decided that some things are safer left unobserved. Because sometimes the easiest way to hide a mystery isn't to erase it. It's to stop paying for the telescope. Let's step now into the part of the story where sound, the absence of it, the precision of it, starts to feel like language. For weeks after 3I Atlas supposedly broke apart, a few radio telescopes around the world kept their dishes pointed at its last known coordinates, mostly out of habit, partly out of hope. What they picked up shouldn't have meant anything, but it did, because the signal wasn't noise, it was rhythm. At first, it appeared as a faint pulse, weak, steady, hiding just above the background static of the universe. One cycle every 16 seconds, repeating with such mechanical precision that the software assumed it was interference, perhaps from a passing satellite or ground-based radar. Yet when they filtered out every known human source, the pulse remained. A researcher at the Green Bank Observatory described it best in a now-deleted forum post. It looked like a heartbeat, built by math. The data was narrowband tight, clean, almost surgical. Natural sources rarely behave that way. Quasars, pulsars, cosmic microwave ripples, all of them smear across frequencies like brushstrokes. This, however, was a single, unwavering tone. It rose and fell in intensity like breathing, but it never drifted off-key. You imagine the scene in the control room. Midnight, the air buzzing faintly from the servers. Someone leans over their console, headphones pressed tight, the static punctuated by those quiet, clockwork blips. 16 seconds apart, every time. It's the kind of signal that would make even a skeptic's pulse match its rhythm. At first, they treated it as an artifact, an echo bouncing off Earth's ionosphere, maybe, or a digital feedback loop. They rotated the dishes, changed calibration settings, switched receivers. The signal persisted. Then, curiously, when they aimed slightly off target 5 degrees, left it vanished completely. Whatever it was directional. Word spread quietly through the research network. Astronomers from Arecibo, Effelsberg, and Parkes all confirmed similar detections, though none published formally. There was a sense of unease, as if everyone had stumbled upon something no one was supposed to find. And then, almost as abruptly as it began, the signal stopped. The date, the 3rd of June, 2020. The same day, NASA released its final statement confirming complete disintegration. Coincidence? Of course, they said. Coincidence is the official explanation of last resort. The agency's radio division attributed the blips to residual harmonics from ground-based emitters and atmospheric reflection artifacts. Their statement was neat, dismissive, and technically plausible, 3 words that have rescued many mysteries from further funding. Still, a few independent labs refused to let go. They replayed the raw data, stretched it, flipped it, ran autocorrelations. What emerged wasn't just repetition, it was structure. Every 8 cycles, the phase shifted slightly, like punctuation. as though whatever was producing it wasn't just repeating, it was looping. A hobbyist in Finland, monitoring with a home-built array, claimed to have caught the final few transmissions before the silence. He described it as a fade, not a cut. The tone weakened over hours, drifting lower in frequency, like a battery dying or a transmitter turning away. His logs, still available on an archived forum, end with a simple note: it left. NASA, when questioned, didn't comment on private observations. They don't have to. When a mystery is labeled noise, it becomes invisible. That's the beauty of scientific triage. You can discard anomalies simply by redefining them, and yet the timing lingers like an aftertaste. The same day the signal vanished, the official record closed. The same week, the planetary defense protocols were updated. The same month, a few scientists stopped answering emails about 3I Atlas. If coincidences form constellations, this one was starting to glow. You can almost hear that signal in your mind now, a soft, patient pulse beneath the static of space. 16 seconds apart, a whisper from nowhere that lasted just long enough to be remembered. Some tried to decode it, of course. People always do. They looked for prime numbers, Morse equivalents, binary patterns. Nothing held up. If it was a message, it wasn't meant for us, or it was too simple to recognize. But maybe that's the point. Maybe it wasn't a message to us, but from something leaving, a farewell ping, a dying echo, or the interstellar equivalent of closing a transmission loop. The researchers at Green Bank eventually labeled the signal Unidentified Narrowband Event, the 3rd of June 2020. The classification code still exists in one of the databases, though the linked file no longer does. Officially, it's archived. Unofficially, it's gone. You lean back and listen to the hum of your own electronics, the fridge, the router, the air conditioner. Each one emits its own faint rhythm, a quiet chorus of civilization. You imagine space doing the same, a universe full of quiet machinery, all humming along, unnoticed. And maybe, for a few weeks in 2020, one of those distant engines turned its face toward us, exhaled a faint, steady breath, and then, like everything else in this story, fell silent. Let's move now into the part of the story where curiosity stops asking for permission. When NASA's final report declared 3I Atlas completely disintegrated, the professional world nodded and moved on. But the amateurs, the backyard astronomers, the telescope tinkerers, the night watchers who live for the faint hum of data, where the professionals see downtime, they didn't buy it. They had their own telescopes, smaller, humbler, but always awake, and together they formed a rebellion of lenses. Across the world, from Spanish rooftops to rural Japan, dozens of observers pointed their instruments at the patch of sky where 3I Atlas had supposedly died. They expected emptiness. What they found instead were faint smudges, dim barely, their glimmers that shouldn't have been glimmering. At first, they thought it was error, hot pixels, dust on the sensor, maybe a wandering satellite trail. But the smudges moved, slowly, consistently, together. Independent observers compared notes through online astronomy forums and late-night Discord servers. Within a week, they had compiled frames taken from multiple longitudes and nights. When stacked, those faint marks formed a pattern, several small points, equally spaced, moving in tandem. Fragments, NASA said, when the data circulated. Coincidental alignment of cosmic ray noise, they clarified later. It sounded official enough. until someone noticed that the timing of the pattern matched the rhythm of the radio pulses that had been recorded weeks earlier. 16 seconds between shifts, the same as the Green Bank signal. You picture them ordinary people in hoodies and slippers, huddled over screens, sipping coffee gone cold, staring at the faint trail of something everyone else had decided was gone. They're not career scientists. They don't have budgets or committees, but they have time and patience and an inconvenient refusal to stop looking. In a way, they were freer than NASA, unfunded, ungoverned, unafraid to be wrong. They didn't need to call it fragmentation or formation. They just needed to see it with their own eyes. Their chat logs read like poetry in pixels. I got 3 points tonight, same spacing as yours. Confirmed here in northern Italy. They're staying in formation. If that's debris, it's the most disciplined debris I've ever seen. Someone stitched the images into a crude animation, a ghostly parade of dots sliding silently through the void. It wasn't cinematic. It wasn't even clear, but it was real enough to make people uneasy. NASA's official stance came quickly. The reported observations are consistent with sensor noise from high-energy cosmic rays. It's a plausible explanation. Cosmic rays can strike detectors and produce random bright pixels, sometimes even lines that mimic movement. But randomness doesn't keep rhythm. Randomness doesn't travel in formation across independent time zones. The amateurs ran their data through filters, subtracted background radiation, cross-referenced timestamps with solar activity. The dots stayed, the rhythm stayed, the 16-second heartbeat stayed, and then, the same night the Green Bank signal faded, the dots did too. One by one, they slipped below detection threshold, fading into nothing as if synchronized with a silent countdown. You can almost hear the frustration in their forum posts afterward, half awe, half grief. Whatever it was, it knew when to stop. Or maybe we just ran out of time. Either way, we were watching something that didn't want to be watched. NASA didn't respond to the amateurs directly. Instead, a short update appeared in the Near-Earth Object newsletter. No confirmed post-disintegration fragments detected. Independent observations attributed to data artifacts. Artifacts. That word again. It sounds so safe, so harmless, like a museum label beneath something that once mattered. But those backyard astronomers still keep their folders. The original raw files, unedited, backed up 3 times. In them, the faint traces remain pixels, arranged in a pattern too precise for accident, too ephemeral for proof. You imagine one of them, a retired engineer, perhaps still stepping outside at night, telescope covered in dew, scanning that same empty patch of sky out of habit, hoping, just once more, to see those moving lights again. Maybe it was debris. Maybe the synchronized pattern was coincidence. Maybe cosmic rays really do tap in perfect time to the rhythm of lost radio pulses. Or maybe, just maybe, what those small telescopes saw was the final act of 3 I-Atlas. Not disintegration, but departure, a formation realigning, adjusting trajectory, fading beyond the reach of both funding and explanation. NASA will never confirm that version. Official narratives prefer silence. But among the amateurs, the quiet rebellion of watchers, there's an unspoken understanding. If you stare long enough into the dark, sometimes the dark stares back. And for a few miraculous nights in 2020, it winked 16 seconds apart. Let's step now into the part of the story where the mystery stops being metaphorical and turns into something you can count, frame by frame, byte by byte. Among the thousands of images taken by the Atlas survey telescopes, there's one missing, frame 1176. On paper, It's just a file flagged corrupted. In practice, it's a small, silent crater in the record, because frame 1176 corresponds exactly to the moment 3 I-Atlas first drifted off its predicted course. The anomaly, if you trace the data logs, appeared at 4:32 UTC on the 19th of March 2020. The object had been following its hyperbolic path cleanly for days. Perfect math, perfect symmetry, until that timestamp. The next observation, minutes later, showed a deviation. Not much, just a whisper of change, a fraction of a degree in trajectory, too subtle for headlines, but enough to make orbital analysts frown. When researchers went to check the corresponding image, frame 1176, they found it missing. The database listed it as corrupted during transfer. The checksum, however, told another story. Checksums are digital fingerprints, unique strings of numbers that prove a file's integrity. If a file is damaged, the checksum breaks. But the checksum for frame 1176 didn't break. It didn't exist at all. That means the file wasn't damaged. It was deleted, cleanly, deliberately. Someone, somewhere in the chain between telescope and archive, decided that frame 1176 shouldn't survive. You can imagine the discovery. A data engineer, late at night, reviewing the logs, line after line of neat entries, and then one gap, a missing checksum, a missing timestamp. They probably thought it was a mistake until they ran the audit trail and saw the command history. RM byte RF 1176. Fit. Manual deletion. Logged from a console with administrator access. NASA's official explanation? Automated error handling. Which sounds convincing until you learn that Atlas's error handling doesn't delete files. It quarantines them. The deletion happened 17 minutes after the image was taken. That's too fast for a manual review, too soon for a damage check, and far too coincidental for comfort. When independent analysts noticed, the story spread quickly through astronomy circles. People began joking about the missing frame conspiracy. The jokes didn't last. Within a week, the log data that proved the deletion was scrubbed from public servers for maintenance. Frame 1176 became legend, the photographic equivalent of a ghost sighting. Everyone had a theory. Some said the telescope caught a cosmic ray burst that confused the system. Others said it captured something that shouldn't have been there. A few even suggested that the missing frame might have shown 3 I-Atlas splitting or transforming. The last theory sounds theatrical, but consider the timing. The frame vanished at the exact second the object's light curve began to pulse irregularly. It's like watching a film where the one missing scene just happens to be the one where everything changes. Some enterprising data archaeologists tried to recover remnants. The Atlas system stores thumbnail previews for each frame, low-resolution images embedded in metadata caches. Frame 1176's thumbnail slot was blank, but its file size wasn't. The system registered that something once occupied that space, a presence without a picture. There's a copy of the index table still floating around online, saved by an enthusiast before the scrub. You can see the gap between frame 1175 and 1177, the numbering clean and consecutive except for that single, missing breath. It's eerie in its precision. The void is tidy. One programmer likened it to a redacted line in a government memo so small it must matter. When people remove a lot, they're hiding incompetence, he wrote. When they remove one thing, Their hiding intent, NASA never issued a correction. In later versions of the dataset, frame 1176 simply isn't listed. The numbering jumps neatly from 1175 to 1177, as if it never existed, which in a sense, it now doesn't. You can picture that invisible frame, the telescope's aperture open, sensors humming, the universe spilling its photons into the CCD array. For a brief fraction of a second, the camera saw something no one else did. Then, before those photons could settle into data, a keystroke erased them. Maybe it really was a glitch. Maybe a solar flare tickled the power grid, or a software watchdog misfired. But maybe not. Because here's the thing about data. It's stubborn. It leaves fingerprints in the log files, even after deletion. And the ghost of frame 1176 still whispers through those fingerprints. Proof that once, for a heartbeat of cosmic time, something unapproved flickered across the Hawaiian sky. Whatever it was, it changed the math. And in a world built on numbers, that's enough to change everything. Let's take a slow breath now and step into the part of the story where conspiracy gives way to something more mundane and perhaps more troubling. Bureaucracies don't always conspire. Sometimes they simply protect. If 3I Atlas wasn't natural, if it wasn't a comet or a rock or an ice ball from the edge of the solar system, then the story we tell about our place in the universe would need to be rewritten from scratch. And rewriting the universe is expensive, politically messy, and career-ending for anyone who signs the wrong memo first. You can imagine the internal conversation. A small room, a low hum of machines, people staring at data that doesn't fit. Someone clears their throat and says, "If this is artificial, we have to tell them." Another older voice replies, "And if we're wrong?" A silence follows, the kind that only grows in institutions. That's the problem with truth in large organizations. It's not that no one sees it, it's that everyone waits for someone else to confirm it first. The higher the stakes, the slower the confession. So perhaps NASA didn't lie out of malice. Perhaps it lied out of mercy. To say 3I Atlas was artificial would mean admitting that the solar system had been visited twice in the span of just a few years. It would mean acknowledging that Oumuamua wasn't a fluke, that our little blue planet might be sitting on a cosmic highway, one we only just noticed after billions of years of traffic. And worse, it would mean answering the hardest question of all. Why now? Governments don't like why now. It's messy, unquantifiable. You can model trajectories and brightness curves, but not panic. You can't budget for awe, so they choose silence. Because silence doesn't crash markets. Silence doesn't require congressional hearings or emergency protocols, or a televised address explaining that a fragment of something ancient and intelligent just brushed past our sun and didn't bother to stop. You can see the logic. If they were wrong, the embarrassment would be permanent. If they were right, the consequences would be unimaginable. Either way, silence wins. There's an old saying in risk management: never announce what you can quietly file. And NASA, for all its wonder and poetry, is still a branch of government. It files things. It classifies them. It buries anomalies under procedure. Maybe that's why so many of the scientists involved in 3I Atlas vanished into other projects. Not because they were silenced, but because they were tired. Because arguing against institutional inertia is like whispering into a hurricane. There's comfort in the official version. A comet fragmented, easy, clean, digestible. The paperwork fits in a folder. No paradigm shift required. And in a way, maybe they're right. Maybe the universe doesn't owe us closure. You picture a meeting where someone high-ranking, exhausted, slides a memo across the table. We'll call it a disintegration, they say. It's the least wrong thing we can say. Everyone nods. No one cheers. It's not villainy, it's maintenance. The slow, careful protection of a public that doesn't want to wake up every morning wondering if we just missed a cosmic visitor that wasn't supposed to exist. Maybe lying isn't even the right word. Maybe it's translation, turning something incomprehensible into something the system can survive. But here's the quiet irony. By simplifying the story, they made it stranger, because the absence of evidence became its own kind of evidence. The missing data windows, the vanished frame, the silence after the signal. It all adds up to something that looks an awful lot like orchestration. People think cover-ups are neat. They're not. They're messy, bureaucratic, filled with tired people making imperfect decisions. Not a shadowy cabal in a smoky room, just a handful of scientists staring at a blinking cursor, trying to decide which truth is least destructive. And yet, maybe they underestimated us. Maybe humanity could have handled it. Maybe we would have been terrified for a day, then gone back to scrolling, shopping, and complaining about traffic. Instead, the silence left space, and in that space, the myths grew. So here we are, years later, sifting through deleted frames and corrupted files, not because we distrust science, but because we distrust the silence around it. Maybe NASA didn't mean to hide the truth. Maybe it just chose the easier version of it. After all, no one ever got fired for saying it was just a comet. And if there's one constant in human history, it's that when faced with wonder or stability, we almost always choose the lie that helps us sleep. Let's take a slow breath now and drift into something older, deeper, and far less cooperative than any government archive: the Earth itself. Because even if 3i Atlas was something artificial, something designed, not born, the planet beneath our feet has a way of hiding such stories. The Silurian hypothesis, proposed by two scientists in 2018, asks a simple and slightly haunting question. If an advanced civilization existed on Earth millions of years ago, would we know? The unsettling answer is probably not. Time, after all, is the best eraser and denial, its most loyal assistant. Imagine this planet not as a world of memory, but as a machine for forgetting. Every 100 million years or so, it clears its throat and swallows its own history. Mountains crumble, oceans recycle the crust, even continents drift and drown. A city, a satellite, an entire species. It all ends up in the same archive: stone, heat, and pressure. The Silurian hypothesis gets its name from a 1970 seconds episode of Doctor Who, where ancient reptilian humanoids, the Silurians, awaken after eons underground. The joke, of course, is that they wouldn't have survived geologically intact long enough to reboot. Rocks don't keep souvenirs. And yet, the question lingers. Could something have lived here before us? Something that built, thought, and disappeared so completely that even its ruins forgot themselves. When you think of 3i Atlas, the idea doesn't feel so far-fetched. We spend so much time looking outward for signs of intelligence: radio signals, alien probes, mirrored sails, that we forget how good Earth is at hiding its own ghosts. If an artifact once circled our sun before, we might not recognize it even if it came back to say hello. The Silurian hypothesis isn't about lizard people. It's about humility. It reminds us that evidence has an expiration date. After a few million years, plastics become dust. After tens of millions, metals oxidize, continents grind, fossils compress into nothing. Even isotopes lose their fingerprints. You might think a civilization would leave scars, skyscrapers, satellites, radioactive waste. But geological time doesn't care about scale. A mountain range is as fragile as a teacup when the mantle starts to move. In the fossil record, humanity itself will barely register as a thin chemical blur, an unexpected layer of carbon, nitrogen, and microplastics. A civilization written in soot. So what if 3i Atlas was a relic of something that once knew this planet better than we do? Something that left, or was flung away, or was trying to come home, and we just called it a comet because we didn't know what else to call it. That's the danger of certainty. When we stop asking, we start simplifying. It's just a rock. It's just a signal artifact. It's just another comet. These are sentences of comfort, not discovery. The scientists behind the Silurian hypothesis weren't conspiracy theorists. They were geologists and astrophysicists. They ran models, made calculations, and found that after even a few million years, the physical evidence of us would be almost entirely gone. Fossil fuels would vanish, concrete would dissolve, even bones would blend into limestone. The only clues would be subtle chemical shifts, isotopic anomalies, maybe a few oddly smooth layers of sediment. To future archaeologists, the 21st century might look like an instant, a flash of industrial fever, erased by time's long exhale. Now stretch that logic outward. What if someone or something existed 100 million years before us? Their traces wouldn't just be hard to find, they'd be geologically impossible to prove. It's a thought both thrilling and humbling. The idea that the universe doesn't owe us uniqueness, that we might be the latest chapter in a book the Earth keeps writing and erasing again and again. And maybe 3i Atlas was a reminder, a fleeting visitor, a nudge across millennia, a cosmic echo whispering, "You're not the first to wonder." Because denial isn't just about hiding the truth, it's about protecting ourselves from scale. We can't imagine civilizations older than our species, or objects built before our sun had company. It's easier to pretend the universe only started paying attention when we invented telescopes. The Silurian hypothesis asks us to look down, not up, to see the ground beneath us as a palimpsest, endlessly rewritten. And if that's true, then 3i Atlas isn't an anomaly. It's a footnote, a reminder that the Earth forgets faster than we learn, and that the next time something extraordinary drifts by, we might already be halfway to explaining it away. Let's step gently into the pattern, the one that's been quietly forming while the rest of the world slept. First Oumuamua, then Borisov, and now 3i Atlas. 3 interstellar visitors, arriving within a few short years of one another, after billions of years of silence. For most of human history, our sky gave us familiar shapes, planets looping, comets returning, asteroids obeying gravity's predictable leash. But then, suddenly, we started seeing guests that don't belong here. Statistically, it's absurd. For centuries, nothing crossed into our solar system from beyond. Then, 3 times in quick succession, something arrived on a hyperbolic trajectory, each one unique, each one unrepeatable. To a mathematician, that's an anomaly. To a storyteller, it's a pattern. You could argue it's simple progress. Our telescopes are sharper, our software faster, our algorithms hungrier. Maybe the universe has always been this busy, and we just never had the eyes to see it. That's the comforting version. The version that says discovery is just competence rewarded. But part of you wonders if something has changed, if the traffic itself has increased. Imagine the galaxy as a vast ocean, and for eons we've been sailing its stillest corner. Then one day, the waves shift, driftwood bottles, even wrecks begin to wash ashore. At first, you think coincidence. Then, you start asking what's stirring the water. The first arrival, Oumuamua, was strange enough a cigar-shaped shard tumbling through space, accelerating without thrust. Scientists called it a rock, a fragment, maybe a comet without a tail. But its motion didn't fit any model neatly. It behaved less like debris and more like something steering gently on its own. Then came Borisov, a proper comet by all accounts, but an interstellar one. Its chemistry alien, its tail richer in carbon monoxide than anything we'd seen. And just as we were getting used to the idea that the cosmos sometimes sends postcards, 3I Atlas appeared, reflective, inconsistent, and uncomfortably clever in its disobedience. 3 messengers, 3 stories, one emerging rhythm. If you plot their trajectories, something eerie appears. Oumuamua came from the direction of Lyra. Borisov approached from Cassiopeia. 3I Atlas from the constellation Draco. Not close together, not identical, but aligned in a loose, sweeping arc. A cosmic breadcrumb trail across the northern sky. Coincidence, perhaps. But so is lightning until it strikes twice. A few astronomers joked, privately, that the galaxy must be holding a parade. Others ran simulations showing how gravitational tides between nearby stellar systems could send a cluster of rogue objects drifting our way debris from a single ancient cataclysm. But the numbers didn't fit neatly. The arrival times were too tight, the angles too coincidental. Some speculated that these weren't random wanderers at all, but fragments of a larger structure, an interstellar convoy of sorts, stretched thin by light years and time. Not ships, necessarily, but relics. Artifacts coasting through space on trajectories once planned by hands we'll never meet. It's a romantic idea, and that's exactly why most scientists avoid it. Romance is dangerous in data. Still, the trend is undeniable. In less than a decade, we've gone from believing interstellar visitors were once-in-a-lifetime events to half expecting the next one to arrive any day now. Each new survey telescope increases our odds. Each new detection pushes the boundary between the ordinary and the improbable. You can almost feel it, the universe turning its head, slowly, to meet our gaze. Maybe we've reached a threshold, a kind of observational awakening. Maybe the visitors were always there, like stars in daylight, invisible until technology dimmed the noise enough to see them. Or maybe, just maybe, something noticed us noticing back. If that sounds dramatic, remember that observation is participation. The moment we look, we change the story. The cosmos has no obligation to remain static once its privacy is breached. So perhaps the pattern isn't cosmic at all. Perhaps it's psychological, a mirror of our growing curiosity, our widening field of view, humanity's awakening to the background hum of the universe. And yet, there's that quiet unease, the one that says, maybe it's not us who have improved, but them who have returned. Maybe Oumuamua was the scout, Borisov the surveyor, and 3I Atlas, the messenger. Whatever the truth, something fundamental has shifted. Our maps of the sky now include routes that come from beyond. We've opened the door, even if by accident, and the silence that once defined space feels thinner now. Because once you start noticing patterns in the dark, you can't stop. And maybe that's the real story here. Not what these objects are, but what they've changed in us. The realization that the cosmos has never been empty. We just finally learned how to listen. Let's slow down now. We've followed the breadcrumbs through data gaps, lost frames, silences, and bureaucratic whispers, and we've arrived at the edge of the map. The question that remains is the simplest one of all, and the hardest to face. Maybe NASA isn't lying. Maybe it's just afraid of what the truth implies, afraid of how small the word comet suddenly sounds when it brushes against the infinite. Because if 3I Atlas wasn't natural, if even part of it was deliberate, constructed, purposeful, then our solar system isn't as lonely as we've always believed. It means that the emptiness we see between stars isn't emptiness at all. It's a medium, a highway, and sometimes something uses it. Think about that for a moment. For all of human history, we've looked up and seen the same stars, steady and indifferent. We've written poems about their silence. We've comforted ourselves with the idea that no one else is watching. But what if that silence was never emptiness, just distance? What if the void occasionally sends back messages, shaped like comets, moving too fast to catch, too strange to classify, and far too familiar to ignore? That's what 3I Atlas really represents, not proof, but permission. Permission to wonder again. Maybe it wasn't a ship, maybe it wasn't artificial, but it acted like something that remembered intention. A light sail disguised as ice, a signal hidden in spin, a mirror that didn't quite reflect right. The fear isn't that it's alien, the fear is that it's familiar. Because to admit that something else out there builds, travels, plans, that it sends emissaries across interstellar gulfs, means admitting that intelligence isn't unique to us, that we're not the authors of awareness, only one verse in an older, endless song. And once you accept that, every silence becomes suspicious, every anomaly becomes a whisper, every comet becomes a question mark, wrapped in ice. NASA, for all its structure, is still made of people, and people are terrible at ambiguity. So maybe, when faced with an object that refused to fit the categories neither asteroid nor comet, neither debris nor craft, they chose the one label that promised sleep: cometary fragmentation. Two words that mean we don't have to think about this anymore. But the universe has never cared about our comfort, because even now, with 3I Atlas long gone, its data trails still flicker in the background noise of our servers. Its missing frame still echoes in archive logs. Its name 3I, third interstellar, still implies there will be a fourth. And perhaps that's what really frightens us. Not that something came, but that something will come again. You can picture it. Somewhere, in the dark, quiet beyond Neptune, another point of light begins to curve inward. It's faint, too faint to register on most instruments, for now, but it's coming, obeying its own mathematics, carrying its own silence. And when it arrives, we'll call it another unusual comet, because that's what we do when language runs out. Still, there's a beauty in that denial, a tenderness. Humanity has always survived by pretending the universe is comprehensible. It's how we get out of bed in the morning. It's how we keep building telescopes instead of hiding under blankets. So maybe NASA's not lying. Maybe it's protecting that illusion not out of arrogance, but out of mercy. Because if you really let it sink in, if you truly accept that the space between stars might not be empty, you begin to see how small and miraculous every moment here is. Every sunrise, every transmission, every breath. Maybe 3I Atlas wasn't a warning, but a reminder that we are participants, not observers. That intelligence might be a cosmic habit, not a miracle. That the universe is busy, and we've just been too quiet to notice. And so, the question that remains isn't, what was 3I Atlas? It's simpler and more terrifying. What happens when the next one comes? And this time, we're ready to listen. Will we still call it a comet? Or will we finally admit that the void has a voice and that it's been speaking to us for a very long time?